In this event today, for our technical talk, we have very special invited guests from Parmarin, Malaysia. They are, yes, clap for them. They are a dedicated group whose long history starts from the year 1968, when the first bathroom elements were manufactured. But I won't be the one telling all this information. Let us watch a video. Please give another round of applause. What an insightful video from Par Marine. Can we please give a round of applause to them? They're really a company that strives for quality for its customers. So everyone, for our first speaker of the day, the upcoming presentation is about sustainable construction. We will be gaining insights about the things that we can do to minimize environmental impact while still enhancing efficiency and moreover elevating quality. This is a session for architects, engineers, and developers. Our speaker has 23 years of experience in the building industry, with 21 years of experience in precast construction. Engineer Lee Wei Thiam is the Head of Sales and Marketing at Par Marine Sendia Berhad. So please, show your appreciation by putting your hands together for our speaker, Engineer Lee Wei Thiam.
Hello. Hi, good morning. Good morning. Thank you for giving me an opportunity to give a presentation to so many, I presume, architects here. So I always look very highly to architects because I've been working in the construction industry for 23 years as an engineer, and I've been working with many architects, and they are all very creative. As you know, engineers are generally very square. So the architect will have to stimulate us to somersault our mind to think, to get the best out of each buildings. And while it's a difficult process, but it's a good learning process. So without further ado, let me start my presentation. Okay, today my presentation will be sustainable construction on industrialized building systems, right? Okay, but this is what I'm going to share with you today based on my experience in the precast industry in 21 years. Well, what are the challenges we have on the traditional construction? It all started with the problem statement. Okay, maybe we straight jump into the introductions. And then as I go along, then I will share with you a lot of site photos, our jobs. And then from there, you have a better idea what I'm talking about on hollow core slabs, yeah, and also the prefabricated unit bathroom. Okay, it all started with the problem statement, right? So as we know that construction is a very important sector in the Malaysia economy. It contributes 3 to 4% of the country's GDP, right? So, and we find that, especially during COVID time, we find that the industry is facing sustainability problem because first, I think during that time, after COVID, a lot of contractors actually find that their jobs can't start because they do not have workers on site, because most of the workers either they have gone back to their own country. As you know, that Malaysia construction industry depends a lot on foreign workers. So a lot of workers actually has gone back to their home country and they didn't come back. And then and all the jobs start together. And then the contractor are facing a problem. I can't get labor. And then during that time also we find that everything starts, and then all the construction materials, the demand actually spikes up. So material costs also shoot up. So to overcome that, so what can we do to overcome that? I think we ask ourselves these questions. I think then we come to conclusions that in order for the construction industry to be sustainable, you have to find a more sustainable way to do constructions. And one of it is to use precast, because precast actually solve one of the key problem on traditional construction, which is labor on site. Most of the things that is most of the activities is actually done in a factory, and then on site you only need very minimum labor on site. Okay, and that is where precast come in very handy. And then also in terms of cost control, because everything is done in a factory environment, so you can actually have a better control on the cost. So this is just some statistics on the GDP. So yeah, as you can see, construction industry is a very important industry. In average, it contributes about 1,506 billions GDP to the country GDP, right? Okay, these are the challenges just now I mentioned. Skilled labor shortage, and then also we find that by using conventional, a lot of time, not all. I think this building, the finishes is excellent. A lot of time we find that the client or the contractor complain to us, say, I couldn't get the kind of finishes that my spec or my customer want. And then also traditional construction practice have very high carbon footprint, and the two contributor to the carbon footprint is actually concrete, because in order to produce concrete, we need to use a lot of heat, and same goes to the rebars. So for traditional construction, the two main ingredients that we use are rebar and concrete, right? So it's not that precast do not use that, but precast we can actually reduce the usage of the concrete by optimizing the design, and also because it's done in a controlled factory environment, we are able to reduce the wastages, right? And then construction industry, in the traditional construction also we are labor intensive, because we need, first of all, we need a carpenter, then we need bar bender, then we need concreter, and then etc. etc. There's so many trades doing so many trades inside the construction industry. And then last but not least is the poor site safety, because a lot of time you can see, once in a while you can see in the newspaper, oh, building collapse. So why does why this happen? Why this happen? Most of the time it happens onto on a site where they are using traditional in situ construction, because a lot of time the accident happened because the temporary scaffold or the scaffolding give way, or it was not done properly, or it was due to human error, so accident happens, right? Like, and also sometimes you can see shortages of construction workers on newspaper, because certain like, for example, during the semicon boom, there is a shortage of labor in Penang, right? And then I think now in Johor everything is so hot, so contractors are also complaining. Hey, it's not that they do not have workers, they can get workers, but they are unable to get skilled workers. So skilled workers and an unskilled workers, the difference are a lot. I'm sure you are architect, you will agree to this, right? So of course, on and off, we will have building material prices go up and down. Okay, so to overcome this, precast concrete system can provide the industry a very sustainable construction method. On the environmental side, while we can actually reduce the material wastages, because like I mentioned just now, everything is done in a controlled factory environment. So the concrete batching, the rebars, everything is prefabricated, and then we only batch so much of concrete as and when we require it, and then it's only the concrete is only traveling within the factory, so you don't have wastages of concrete hardening and things like that. And then normally in a precast factory, we try to strive energy efficiency by using solar panels, green resources. Like for example, instead of diesel, we'll be using LPG, right? And also in the factory, we also go into recycling the aggregates. Like for example, sometimes when we batch concretes, and then we still have a little bit of leftover, we can actually recycle the aggregates for the next batches, right? But one thing that is which is the trend now is a lot of precaster actually are using green concrete. I'm sure some of your projects you expect the contractor to use green concrete. What do you mean by green concrete? So in the industry now, I think some of the more sensitive segment, like for example, semicon or data center, some of the client actually wanted to cut their carbon footprint. So what they will do is they will ask the precaster, say I want to reduce my cement consumptions. I think in Singapore we do have 1 tick, 2 tick, 3 tick, 4 ticks, right? So what is 1 tick, 2 tick, 3 tick, 4 ticks? The definition, the higher the tick, that means the lesser amount of cement that we use in the concrete. We will replace the cement with something else, for example, fly ash or GGBS, right? Or any other materials. Okay, same goes to reduce the carbon footprint. Alternatively, we can also use recycled rebar. I mean, not rebar manufactured using recycled rebar. Yeah. So that means it doesn't go and extract iron ore and the coal to manufacture it. Instead, they are using they collect the recycled bars from the market and then they reuse it. Then what are the economic benefit on using precast? Precast is a precast is a fast track construction. So precast is faster than normal conventional construction. It's only slower than steel construction. So normally if a client say that, hey, I want the job to be a fast track job, the first thing that comes into mind is steel structure. Follow closely behind that is actually precast construction, right? And also, like I mentioned just now earlier, it actually reduces significantly on the labor cost. And then also for precast, as like concrete, it is very low maintenance and very low maintenance cost because it is concrete. You do not need to go and do painting every year and things like that. Like the steel structure, you have to maintain it regularly. But for concrete structure, concrete is concrete. You last you a very long time. Social benefit, it improves site safety because most of the precast construction in the market, we are using unpropped constructions. That means unpropped means when we launch the components, especially the beams and the slabs, the horizontal components, it is unpropped construction. Means you straight away launch the beam, you straight away launch the slabs, and you do not need to prop it. So that will eliminate just now the kind of accidents on site where the scaffold give way and then the whole thing collapse. So with precast construction, you don't have that. And also you will get a cleaner site. The site for construction site, precast construction site is very clean. Why? Because you do not need any formwork. Because if you go to any sites, the rubbish that you generally see majority are formworks. So for precast construction, all the formworks you almost eliminate 99% of the problem. There will still be a bit of formal on here and there at site, but majority of it is actually done in a factory already, right? So with your precast building, will give you a better living environment and high quality products. Like for example, you have a better finishes. So like for example, some client like IKEA, so they have actually very stringent finishes requirements, and they normally just want to have the concrete off-form finish kind of features. So that is something that can only be achieved with precast. And you can see on the picture here, this is a typical precast factory layout. It is a long building, covered building, then with a precast facility. These are normally pre-stressed bed where we can put the tendon, and then we can cast the hollow core slab or whatever precast components on the bed. And they will normally have a batching plant in the factory, and then it's delivered automatically within the plant using this shafter. All right, so precast construction also, like I mentioned just now, it actually reduces carbon footprint. So based on Wong and Lu 2022, Sustainability Implication of Using Precast Concrete in Construction, an in-depth project level analysis spanning 2 decades, from Journal of Cleaner Production. From that research, we found that precast building have 25% smaller carbon footprint. And also you have 1/3 less cement on concrete and lesser steel bar per meter square of floor. Why is it so? Because normally precast construction we use pre-stress technology. So generally the sizes are smaller, and ultimately precast reduces CO2 emission, minimize wastages, and lesser material is used for precast construction. So you can see in this picture here, this is actually a typical factory layout. While you can see, we actually uses this solar panel. Actually, solar panel from our data, we just implement this last year, and then based on our current data, actually solar panel do save us quite a lot of costs in terms of energy usage. And we also have, like I mentioned just now, is in our products we uses green concrete. Green concrete means we are replacing cement with alternative such as fly ash and GGBS. And then also for the key ingredient sand, instead of using river sand, we can also use manufactured sand. What is manufactured sand? Manufactured sand is actually a byproduct of quarry. We actually crush the rocks and then make it into sand. And the advantages of manufactured sand is actually more consistent. I think in the supply are also more, more sustainable, because river sand sometimes we will face problem of, you dig so much and then it polluted the river, then the authority will come in, hey, stop, you can't. So we will have supply issue. But if you use a manufactured sand, your supply is very consistent because you actually crush it. You don't go and dig. Recycling of wet concrete. Just now I mentioned wet concrete, if you don't use it, any wastages, you don't throw it away. What we do is we recycle it, use back the sand and aggregate. Energy management, solar panel. We also use LED lighting. And then also now, because everybody is talking about ESG, environmental friendly, so all our processed water have to be treated before it is discharged into the river. Otherwise, DOE will come after us. right? Beside what I have mentioned just now on green concrete, actually we are currently developing this cement, concrete. It can actually replace the cement content up to 95%. That means we only use 5% of cement in that concrete only. There is such technology at this moment, but it's still in the development stage. And beside that, there's another technology called carbon cure technologies, where they actually buy the carbon that is captured from the environment, and then they pump it into the concrete to enhance this concrete strength. That's another new technology. It's already been used in US. In Malaysia, I don't think so. And another one is, just now as I just mentioned, is the use of scrap for EAF rebar. EAF means electric arc furnace rebar. So where are precast system used in Malaysia? Generally, it has been used in all kinds of buildings, residential, industrial, commercial, public buildings, even in infrastructure projects. So in the next slides, I'm going to show you these are the typical precast components that are used in Malaysia. The most common one is actually Holocaust slab. Well, the advantages of a Holocaust slab is it can actually span very long. In Malaysia, we have done Holocaust slab up to 16, 17 meter. During construction, you do not need to prop. Later on, I'll show you some site pictures where you span the slab 16 meters and you do not need to prop it. And Holocaust slab normally are able to take higher load because it is pre-stressed. And also, then beside Holocaust slab, we have other slabs. We have the double T slabs. These are generally used for industrial buildings. And we have precast plank. And then for columns, it's just like any columns. But normally precast column, we will have a bit of corbel. Some architect may say, hey, corbel very ugly. But we try to make it nicer by introducing a funnel-shaped corbel. Later on, in the photo session, I can share with you some pictures of columns with corbels. Well, then you can tell me whether it's acceptable to you or not. Of course, we will have beams. Beam, it can be a RC beam or a pre-stressed beam. Normally, if the beams are very long, then we go for pre-stress. Or sometimes the client may have a structural depth constraint. Then we will have to go for pre-stress so that we can actually reduce the overall depth of the beam. And we also can have precast wall. These are generally buildings components. Then for infrastructure, we can have tunnel segment. There's like your MRT tunnels, where you go underground. After you dig the hole, you need to have a tunnel lining to form the shell before you do any activities inside the tunnel. And then and also railway sleepers. Well, there is no more timber sleepers. All the timber sleepers has been replaced with concrete sleepers. So because it can last longer, timber sleepers, they have to change it regularly. But for concrete sleepers, it can last very long. Last but not least is this what we call the prefabricated unit bathroom. So prefabricated unit bathroom is a system where, as you know, that in conventional construction, bathroom is a very small area, and it involves a lot of trades. Like you have your tiler, and then you have your sanitary fittings, and you have ceilings, and you have your electrical guy, you have your plumber, and things like that. So what we do here is we actually transfer all this trade into our factory. We build a concrete base, Then we form the wall using a steel frame, and then we put all the tiles inside, all your finishing inside, and then complete with walls. And then we just need to deliver the whole unit to your site. The advantages of prefabricated unit bathroom, just now what you saw in the video, is that we have water tightness warranty. I think that is the most headache thing currently faced by the industry. Because this is done in a factory environment, we check each and every one of the units before it is actually delivered to site. So you can actually eliminate that problem. And beside that, we have done one job in Singapore. I think that is NV residence, and the spec is very stringent. So the gap between the tiles cannot exceed, I can't remember how many mm. So the only way to achieve that is to do it in a factory, because to do it in a factory, we actually have a template and equipments to use it, to do it, yeah. Okay, the next session is all the photos lah. Just now I mentioned, just now what I told you those are just in theory. So now we apply the theory into the actual job site. So in this building here, it is a quarters. It is a quarters. And what we did here is we actually do we call it a multi-tier column. So the column goes up, then we will install the beams, then we install the slabs. For this construction, again, you can see later on in all the photos, you do not see props or very minimum props on site. What you see is the columns, the beams, the slabs, and then your cranes. Next is schools. A lot of schools, I think government job schools have to be precast, have to be IBS. So precast is one of the system. And normally schools are, for schools, normally we'll use precast column, precast beam, and then precast slabs. And also what we normally do is it's unpropped system. So you don't see scaffold in the site. And this is IKEA. In fact, in Malaysia, there's 4 IKEAs. We started off with Damansara, then Cheras, and then we have Tebrau, and then lastly we have Batu Kawan. All 4 IKEAs are a total precast building. I can show you here. For this one, this is IKEA Johor. IKEA Johor, we are using precast column, and then we have precast beam. The grid is actually 8 meter by 16 meter grid. So you can see this during construction. This is actually a fast track construction. You can see on this part of the building here, we start building, we jump start the ground floor. The contractor later will come in and do the ground floor. And then on the left hand side, you can see the foundation work is still ongoing. So we actually can work very closely with the foundation work. And what you can see here is the hollow core slab is spanning 16 meters, but it's unpropped. The beam is spanning 8 meters, it's unpropped. So you can see that the productivity to do this is very high, because you do not need to erect any scaffold, and you don't need to remove any scaffold, and there's no formwork. So everything, you come in, you just install the column, install the beam, install the slab, and then you go on. And of course, on site, they will need to do some very little in situ work, but that is only consists of maybe less than 20% of the overall work. And this is IKEA Cheras. I mean, all the 4 IKEAs may look very similar. It's a blue squarish box. Size is almost the same. It's about 80,000 meters square, or in square feet, it's about 80 to 100,000 square feet. No, 100,000, 1 million square feet, yeah. 800,000 to 1 million square feet. So, but in this job here, this IKEA Cheras, the system is slightly different, because just now you saw the earlier slide, the beams are 8 meter span, the hollow core is 16 meter. But for IKEA Cheras, it's the other way around. The beam is longer, 16 meter, and then the slab is shorter, 8 meter. So after we have done this, and IKEA decided, hey, I think the other 8 meter by 60 meter looks brighter. So it go back to the 8 meter beam, 60 meter slabs in the end. Okay, this is IKEA Batu KHUAN. So you can see, just now we saw the pictures from outside. So internally, this is how it looks like. The columns, the beams are 8 meter span, and then the slabs are 60 meter. And this is what I meant just now, the columns with funnel shape corbel. So we try to blend the column to the beam. If you can see on the left-hand side here. So normally the corbel, we make it as wide as the beam so that you don't see the sudden change in size. And then for hollow core slabs, you can also have services hanging below it. You can see all these services, your fire pipes, electrical, all hanging below it. And at certain area, you also have openings. We can also form openings onto the hollow core slabs. And okay, for this job, we also have precast. Actually, for all the IKEA job, we also have precast wall. Like I mentioned just now, what they want is they want concrete, not fair face, concrete off-form finish. So they want the concrete color, and then you can see in all IKEAs you have very minimum painting. They try to show the concrete color to the buildings, concrete color and metal cladding around it. So this is how it looks like at the staircase wall. I'm not sure. I think this is a staircase wall area. So and these are the soffit of the slabs. And this one is during the construction. You can see again, everything is unpropped. You can also observe very minimum labor on site, but the only thing you see is cranes and lorry coming in to deliver the goods. Okay, this is another interesting job. This is Robert Bosch car park. Again, this is also a long span construction. The grid is also 8 meter by 16. I think this is 16.5. This is slightly longer, 16.5. And what we did, because this job is next to the runway, the Penang Airport runway. If you take Air Asia, you go down to Penang Airport, you can see on the right hand side there's actually a car park. Actually, this is actually the runway. So it's very near to the runway. There's a lot of restriction on your machinery height, and also your working hours. So in order to do it fast, to do it quick, what we do is we introduce multi-tier columns, and then we do the floor by floor on the beams and the slabs, and we try to minimize the number of components to install on site. So again, you can see these are all unpropped. You only see cranes and lorries and very minimum workers on site. So I think by reducing the number of workers on site, contractor have a better certainty to complete the work. Because the most difficult part is to manage your workers. And this is another car park in Ipoh. You can see all these planter box. These are features. These are actually precast components. Bring it nearer to here. This is a warehouse in Bukit Raja. It's actually 12 meter by 12 meter span, and then the height is also 12 meter high. And this is Shopee warehouse. It's a 2-story building. So the ground floor is conventional in situ. First floor is a precast beam and hollow core slab, and then above that is your metal roof. wait, before that. So you can see, especially for high floor-to-floor height construction, to erect a scaffold 12 meter high is a very tedious activity lah. So in this case here, the beams and the slabs are unpropped, so it actually saved the contractor a lot of money, and save a lot of time. So time to erect the formwork, time to dismantle the formwork, you actually take away those time and costs. And this is quite a recent. No, this is quite a recent job. Or recent means less than 3 years. This is a semiconductor factory in KHUAN. You can see that there is an existing building here. There's an existing building. The new building is connected to the existing building. So this job again is a total precast building, precast column, precast beam, and precast hollow core. And this one is even more recent, last 2 years. This is a front-end semiconductor factory. Front-end means the factory is actually doing doing chips. So the requirements for front-end building are more stringent. So normally for front-end semicon factory, we will normally have these vibration requirements. I mean, means that actually every buildings you have vibrations, but for this kind of building, they limit their vibration to a very small frequency, so that you need to overcome this. What the engineers does is they make the slabs, or they make the building very heavy. So as you know that when the buildings are very heavy, even though there is vibration, it actually dampen it, so you don't feel it so much. So to do this, we actually use waffle slab for this kind of construction. And again, all these are all unpropped. You can see there's not many or no props on the precast area. These are the in situ areas, so you need props. And lately, I think there is a lot of data center, and this is one of the data center in Sedenak, and it's also a fast track job. And we actually, okay, this is also a long span. This is actually 17.5 meter, because it's 17.5 and the load are very heavy, so we can't use hollow core, but we have to use double T slab for this. And it's a total precast building, precast wall, precast column, precast beam, and precast double T slab. And you can see that in this job, we have cranes sitting on the ground slab. The ground slab is reinforced to take the crane load, and then we will install the precast component from inside. And then from outside also, we have a crane to support the perimeter as well. So this job is about 60,000 meters square. We separate into 2 phases. The whole building is supposed to complete in 6 months. Yeah. It's already completed. And this is another data center. This is in Singapore. It's also a total precast building. And as you know, Singapore land is very expensive. So normally their data center are very high up. This is a 10-story data center. So it's very huge. It's also using total precast, precast column, precast beam, and hollow core slabs. The delivery is from Malaysia. We delivered all from Malaysia. Oh, this is a very unique building. This is a Pinewood Studio in Johor, because the client actually wanted a very high concrete wall to form the box, and it's empty inside. So what we did here is we actually introduced the precast columns, and then the precast wall actually hold on to the columns. And then the wall is actually average about 12 to 15 meter high. So it's something different. We only do it one-off. Only this job is using this system. And beside that, precast can also be used for tunnel segment and also railway sleepers. And then this is a case study on prefabricated unit bathroom. Like I mentioned just now, we will have the concrete base, then we will have the metal frame, then we have drywall, then we will have tiles, and then your sanitary ware, everything is fixed inside. And we delivered the whole unit from our factory in Baranang all the way to Singapore. Okay, so those are the photos. Well, what are the challenges and solution for IBS in Malaysian market? The challenges are high initial costs and it's very capital intensive. And then well, people are complaining that limited skill force for precast production and installation, difficult to get people to do installation, and logistic and supply chain issue. Logistic means some of the components where if it's too big, we will not be able to deliver it from the factory to the site. So the solutions are well, government currently have incentive for investor who want to invest in green technologies, and then for workforce and training and capacity building, I think CIDB has done a good job. They actually have a lot of courses to train people in terms of production or be it in the factory or site installation. They are continuing to train people up on that. And also governments have introduced a lot of TVET schools. So actually government has done quite a lot to train people in the industrial building system segment. And to improve supply chain management and local partnership, that means we can actually try to talk to the supply chain. For example, Malaysia currently facing for the IBS industry, Malaysia currently facing problem of crane. Why? Because in Malaysia, it's very difficult for contractor to get a big capacity crane. For example, tower crane. In Singapore, their tower crane are able to lift 35-ton component easily, right? But in Malaysia, you ask a contractor to lift a 10-ton elements, the contractor will say, wow, how to find my tower crane can only lift 1.5 ton only, or maximum 3 ton only. So we need to talk to the, I think maybe we can talk to the government sector as well, so that we can give some incentive for those crane suppliers to bring in bigger cranes, so that they can actually help the industry to, because a lot of time for precaster, our limitation is actually on the cranes. If the crane, like for example, high rise, a lot of time our constraint is actually on high rise. When contractor come to us and say, hey, I want to do this, and I want to do a precast column beam for my tower, can or not? I say can be done. We've done it in Singapore, but in Malaysia, if you can resolve the logistic issue, you can provide, you can get hold of a high capacity tower crane, then that things can be done. But the problem now is very difficult to get those big capacity crane into the market. Chloro crane, no issue. Chloro crane, we can get up to 600 ton. We are using that already. But tower crane is a challenge for us. Yeah. Okay, so what are the future trends for precast concrete system? The future trend, what I can see now is, especially data center, they are actually going all in to reduce carbon footprint, right? And they also wanted us, basically they want everything to be green. So renewable energy, to use green concrete, to use recycle rebar. These are the trends. Of course, nowadays if you are not, just how I just mentioned, I just talked to NWA. BEAM is now a prerequisite for some of the jobs. So a lot of things actually are using BEAM. So that will help us to improve in terms of our productivity. And then last but not least, we need very close collaboration between the public and the private sector lah. So this is my conclusion. So precast concrete systems are vital for sustainable growth because you cannot keep on getting foreign labor into the market. I mean, you need to improve your productivity. One way to do that is to go into IBS. And the benefit of precast construction is reduce construction duration, the speed, reduce labor on site, reduce your carbon footprint, you have a better quality, and reduces your wastages at site. So what are the recommendations? To embrace precast solution for large-scale projects, because if your job is, you have economy of scales, and your jobs are very modular, you can actually reduce your cost quite significantly, right? We need support policy to promote green and IBS adoption, and also to enhance collaboration between manufacturer, developer, contractor, and regulator. I think with that, that's the end of my presentation. So, any questions from the floor? Or the next speaker? All right.
Thank you. Thank you so much again to Engineer Lee Wei Thiam. That was such a great presentation with so many points to take away, really, really. We've truly deepened our understanding of precast concrete. Wow. So, next on, our next session is an IBS case study. Today, we are privileged to learn from real-life examples, two iconic landmarks. The renowned Taylor's Lakeside campus and the sleek modern MENARA KHUAN. Our speaker brings both technical depth and hands-on insight to the conversation. We are honored to welcome a distinguished architect whose design journey spans continents. Architect Ar Ng Wai Keong is the founder of NWKA Architects and a graduate of the Welsh School of Architecture. He began his career in the UK in the 1980s. Returning to Malaysia in 1987, he co-founded LAKESIDE and went on to lead major developments like the Proton Center of Excellence and Nilai Cancer Hospital. Today, he continues to champion thoughtful, design-driven architecture through his boutique film, guided by his philosophy that success is by design. Please welcome to the stage, Architect Ar Ng Wai Keong.
Hi, morning everyone. Thanks, Pam, for your invitation. The second speaker is always a little bit of a struggle because I think, to keep your attention and all. So I'll try and keep it brief and short. The IBS experiences that we have is not just limited to this two, but I'll be touching on a little bit more beyond this, and also to possibly look at what the future will be like in the IBS systems. Okay, let me try. Taylor's Lakeside campus. We were invited to be the architect in 2006, and that was the site when we went after we were appointed. It was a ex-mining pond, and it was also where the waters from the Klang River used to flood every December. And this was what we've done after. So if I can just show you the Klang River, and this was the campus. And prior to us putting on the campus, this was what it looked like. So we had 2 years, just over 2 years, to fix the, oops, sorry. Let me just go back. We had to put the campus there, and the lake was that size, that mining pond. And where I was saying the flood comes in, it was from the river there. And then when we got onto the site, we realized it's not just an ex-mining pond, it was also a dump site. And we've got lots of squatters on the land. And we had a whole bunch of gangsters who had possession of the land, so to speak. So these are the challenges that we face. And as we got on to look at it, there was a lot of pollution into the land as well. So before we can actually put up the campus, we had to actually clear all these things before the work can actually start. And over on top of that, if that's the LDP, we also had to come off the interchange, so we had to deal with LLM as well. So you can see all these challenges prior to us starting the work for the campus. We had just over 2 years to do it. So the challenges are actually quite substantial. And that was what was proposed on the site with the campus. And one of our intention was also to retain the lake. And all this meant that there was a lot of preparation that we had to do before we can actually build the building. So that becomes a problem as far as construction is concerned. The decision then to go on to precast became a viable option. One of the things that we did was, whilst we were clearing the land, the production and the planning of the campus itself could go on more or less simultaneously. There was a cost involved, but at the end, we did not actually come out to be more expensive because we've had to manage other areas in order to compensate for the cost that we had to pay the precast guys. So the campus in brief, on the lower floors were where the hospitality school is. So we had lots of kitchens and back preps and everything on the ground floor, or the lower ground floor, and having to deal with the water levels and everything. And then above that, we had a whole series of lecture theatres. And then above that, the faculty offices. And then above that are the classrooms and the teaching facilities. So this is a view of us having reclaimed the land, and we had to dig up the entire lake in order to clean it, and then refill it with fresh grounds, and then allow the water to fill it back. And in the course of doing it, we also had to control the water from the Klang River, so we had to put in a stop gate as well. And as you can see, we haven't even started on the access from the highway because we were talking to LLM. So gradually, as it took shape, we started to prepare the ground, and it was getting ready. And then eventually, the first pile was ready to go in somewhere in 2007, end of 2007. And the owners were there as well. And some of the precast systems that Lee was talking about, we've actually worked with them to get the hollow core slabs and the columns and the beams. These are just some indicative drawings of what we did. And you can see that the whole thing, we've used the precast systems right through, columns, beams, stairs, planks, and even for the lecture theatres, when we actually had to step down on the terraces for the lecture theatres. Yeah, the stair details. And junior production, we went on to visit the production factories as well. And this came along. And eventually we started on site. As the lake filled up, the floor steps were prepared, the ground conditions, and then we started with the precast systems coming up from the lower ground floor. And the building went up. So this is by 2008, middle of the year, we were up onto the 3rd floor. And it went pretty quick from then on because we had almost just about a year to deliver the entire campus at that point in time. And it went on up. You can actually see that the slabs are all in, and we've got the BRCs on top to put the screed over. The lift cores themselves were in situ, but the rest of it was precast system that we have used. The services were put underneath as and where is necessary for the drainage or some of the cables. And in the meantime, we were also at the same time monitoring the lake, because with this resurfaced lake, the issue here is whether we've actually been able to keep the water in, and if there's any leakages and the rest, and if there's any rectification that we need to do. All right, yeah. And then eventually, as we come to the finishing stages, the services started to come in. And there was quite a lot of design coordination as far as the services are concerned, because with the hollow core slabs, you had to predetermine where the services goes, and also how do you then manage the services as part of the overall aesthetics. One of the decisions that we've made is to actually keep the precast as part of the architecture, so it's got that industrial look about it. And the services therefore became very important in the way you want to organize it. So what we have done is to have actually created this central spine for the services to run. So we've ran all the aircon, electrical, fire, and telecommunications on this rack that ran down the spine. And in order to keep that look aesthetically, the services, as it branches out into the various spaces, it goes up, it doesn't go down. And what we then did was to have the sleeves, which are all allowed for within the beams. Then we have the ability to keep a clean look on the bottom of the service spine. And whether it's aircon, electrical, or water, it all goes via the same way. Okay, and as we come closer, the buildings are up, the lake is taking shape. And then we went on to the facade works. One of the things about this building, originally we intended for it to be panelized, but because of the cost issues, we had to mimic it using block work to create the panels, which we thought was reasonably effective to get that look. So we spaced it between the glazing and the panels, and then had the joints exposed as part of the architecture to create that symmetry and also the regulation of how the modules were going to run. Okay, and as we come towards more or less 3/4 way of the construction, it started to take shape, and you can see the modular systems are actually quite predominant in the how the architecture is being expressed. And later on, as we complete the finishes within the interiors, one of the things about it is the rest of it was all exposed as precast, but the floors we had to screed it, so we had to control the level of that floor as well, and quite a lot of it was using actually the concrete as part of the floor. And as we are coming closer, as the academic blocks were being finished off, the administrative block and the front was also being completed. And this is a shot from the boardwalk. The difficulty was in terms of establishing the buildings relative to the water, relative to the tide. Because we are so close to the Klang River, the threat of flooding is always there. And we actually created this differential to allow for a meter of water to go up and down. In the event that the Klang River gets too high, we actually close it off with the controls, and that stops the water from backflowing into the campus. But I think in the last 13 years, we had one situation when we had a flooding in here, and the reason for that flooding was because it wasn't from the river, it's because we actually stopped the outflow. And the amount of rainwater that came into the campus was so much that it actually filled up and flooded the lower ground floor. And the big difference was when we had a drone shot, the water inside the campus was clean. It's clear water, but the ones on the outside was all muddy. So in that sense, it protected the campus. All right. Oops. Yeah. Okay. And we were getting quite close to the finishing. And the phase 2, which was the hostel part, was still under construction. And the final finishing of the glazing and all that came in literally towards 2009. Again, it was fairly fast track. Here are some of the pictures of the finished campus at that point in time. And because of the cost constraint, we also went for just a screed finish without the actual finishing. But over time, we've actually replaced them with tiles as well, as it didn't wear very well over time. And some of the interior spaces that we have. And this was the administrative block with the multipurpose hall. And some of the exposed precast systems that we've got in together with the stairs. One of the things that we are very proud of is the fact that we have always been inspired to come up with a passive design, and we wanted to encourage people to walk rather than to use the lifts. And the way that we've positioned these stairs is so that it makes it accessible between the floors, especially on the main circulation areas. And it was quite gratifying that you see students using the stairs rather than trying to jump into the lifts and go up and down. Okay, the lecture theatres, we had a couple of lecture theatres where we had a view over the lake as well. Again, that precast system is actually that external wall that keeps the view. And the tiering of the lecture theatre is all precast as well. Okay, and one of the features that we had was having this span, because between the blocks, we had this concourse, the undercrofts for the main circulation areas. And we've asked the precasters how far they could actually span in one single span. And in this case, it was about 40 meters. And what we've done is we've actually lined it as part of the architecture, and then in between to have introduced the skylights, so that we've got sufficient space between the precast slabs to allow for the light to come in, and at the same time possibilities of movement as well, given the fact that it is actually open to the hot sun. And one of the interesting things was this precast slab over the long distance had a camber to it, so we had to put in the screed above to eventually over time allow it to settle and form the gradient that we wanted. So it was quite interesting from an architectural standpoint, because we always look at drawings and we think everything is flat, but it's not, because materials do change and there is a life to it as well. These are the things that you will learn as you go along the way. And then the drainage becomes an issue. So we've actually provided for the drainage on the outside, on the undercrofts, from each of the panels to take it down the central core, which is just on that side. And this was almost finished at that time, and eventually it was, and it looked like that. And I think most of it still looks like that today, but the big difference is that the landscape have grown, and it's been operating for about 12 years already, I think. 12, 13 years, 2009 until now. 15 years, 16 years, sorry. Quite a while. Okay, so that's Taylor's University. The next one is MENARA Kuan Chew. MENARA Kuan Chew is a little piece of land that you see above. It is by Pavilion Bukit Bintang, in front of the Pavilion Towers, where the corporate headquarters for Pavilion SWASTA. And they have decided to put up another office block right in front of Pavilion Towers as the private offices to the owners. And when you look at the site, it's less than half an acre. It's about 20,000 square feet. And it's ringed by everything else except for this piece of 20,000 square feet land. And sitting on it was the sales gallery that they had for the Pavilion residents at that time. And when we started work, this was what it looks like. We've got the 4-lane highway, Raja Chulan, on the top side, and then the car park access on the right, the car park egress on the left, and the drop-off areas for Pavilion Towers. So in that, we had to build this building, and whatever that you need to come in and out for the contractors, it became a huge problem. So again, bearing in mind the constraints of the site, having a manufactured system done outside the site makes a huge difference to the way that we can actually build this. So these are the plans. The basement areas are actually the car parks, and we don't have space for the car parks either. So we've actually incorporated an automated car park system. And then on top of it are the lobbies for this plan, and then beyond that are the typical floors. So this is the automated car park. It is another interesting development from the point of view that everything is manufactured off-site, and we are able to incorporate the number of cars that we wanted to, compared to a conventional system where you would have probably got to go down quite a few levels, bearing in mind that there's a limitation in terms of how you can run the RAMs and everything else. Okay, so as the building takes shape, or the foundations take shape, you can actually see that there's not very much of a working space within the site. And we've also got to bear in mind that there's a functioning shopping mall at the same time, and traffic is going past us all the time. We've gone for this thing called a bubble deck system. The whole idea of a bubble deck is to reduce the redundancies in the usage of concrete, thereby reducing the quantity of concrete. And this is what bubble decks looks like. They come manufactured with a base plate, and then we've got the balls on top, and then the BRC above it. And the whole idea is that you lay them all, and then you concrete at the top. So the balls actually reduces significantly the amount of concrete that you require. And this is what the plan looks like with the bubble deck. So the columns are in place, and then you run the decks above, and then you concrete the entire thing. And during construction, this is what you see. And obviously, we are very, very close to the existing building. What separates it, essentially, it is just a drop-off area, which is about 6 meters. And in that 6 meter, we also have the canopy, and we are literally within 2 meters or less from the construction site. Yeah. And as these guys are installing these, once they've got all of it prepped in a sufficient pour area, then they'll actually concrete the slab. It's a very interesting system that again demonstrates what an IBS system can do. All right, and again, this helps us in terms of number one, reducing concrete pours. All right, and at the same time, allow us to do it in a fairly consistent manner. The pours, it's a very regularized concreting, but much less in terms of the quantities that we require. The entire facade are based on a unitized system, and there's a combination of granite and glazing. These are some of the details. We've always got the granite in front, and then we've got the aluminum back panel, and then the various drainages that we need to contend with. And here are some of the granite that the manufacturers have done. So we've go through this process of pre-selection to make sure that they are all consistent. And then we've laid them out so that we know that they are all in line in terms of the elevation, to take away whatever discoloration or defects or any thing which we think is not correct. Yeah, more pictures of it. And this is a detail of the typical column positions. Essentially, the stone actually is on the outside that expresses the column, and then we've got the back stone, so that you get actually a layered look to it. And we've also maintained a flash gap between the front and the back. All right, and then the aluminum back panel seals the internal side of the building. That's what it looks like, the expression of that granite column. So the entire thing is fixed onto a stainless steel unitized system and is cladded on like that. So it's fully drained at the back. And the final look is like that. So we've got this flash gap along here. And then the glazing then goes in so that you get this very tiered look to the elevation. And the finished product looks like this. Okay. Originally, we wanted to light up the flash gap so that you actually get a glow, but we then realized that you cannot actually replace the lights because the flash gaps are just too narrow. So we didn't go ahead with the lighting at the back. So it stands like that today. And a lot of the variations then comes in the entrances, that we express them in different colors. And then the canopy over the drop-off area. Okay. And the final look is like that. Okay, these are some of the interiors. And generally, it's very much a stone finished interior, and we've expressed that on the outside as well, for that very corporate look. This is the lobby, and some of the finishing onto the facades, screens, and the detail right on top. Okay. Now I want to take you to something else beyond these two buildings, the PPVC systems. We've also experimented with PPVC systems, prefabricated, pre-finished volumetric construction. And we did this in Kuala, Damansara. Essentially, these are apartments, and they were manufactured off-site and then brought on to site to be assembled. It is okay. Maybe I'll tell you that later. What we did was we had to build the stairs first, and then the corridor areas to lock in the PPVC systems, which looks like that. So a typical module It's 6 to 7 meters. It's about 3 meters wide, and the whole thing is actually of steel, and it's what's known as a candle lock system. The whole idea of this is that it's a steel box. It's all pre-finished, and then it's locked into place at the corners using this thing called a candle lock system, all right, which is fixed on these kind of points, so that you actually stack them up and lock them in. They are manufactured, again, in the factory. So all the finishing is done off-site in the factory. And then it's transported to the site of these prime movers, and then lifted and stacked on top of each other. And this is a typical unit. So we've got three modules, 1, 2, 3, and then we lock them in sideways, and we lock them in above as well. Okay, so as we stack them up to the 3rd floor, and then eventually we've got this finished as a 5-floor typical apartment. This was very interesting in a sense that we did it out of steel. I don't think too many people would try steel because of the cost, but it definitely was very precise. And as Lee was saying, the finishing was quite incredible. The tiles all line up right down to the millimeter. The door finishes, the frames, everything fits as what it should be in your drawing. And when they put the modules together, it fits, and what you need to do is then just seal the joints. But they all actually come within the tolerance. So your usual CPC inspections, it is really, what's the word, easy relative to what you would see in normal construction. All right, and this system, because of the precise nature of the PPVC, it makes it much easier to control the tolerances as well. And the candle lock system actually helps to give you that adjustment. It's a brilliant system, I think. But however, the cost was prohibitive. So after having done all that experiment, we couldn't make it work financially. So there you go. But I think it's a good test for the future. And as I was saying earlier, one of the things that's facing IBS is the fact that we have a challenge between the cost of labor and the cost of production. And that's something that we will continuously face until we sort that one out. Okay. And then we tried also a concrete version of the PPVC. We did 5 Putrajaya schools. And this one, we had a challenge of having to build these schools in 2 months, in between breaks. It's not new schools, these are additional classrooms to the schools. It was during the end of the year break that they wanted us to add these classrooms. So in doing so, it is actually quite a challenge because, again, a lot of the pre-planning that we had to do was much earlier to get the design sorted out, get it manufactured, and then delivered to site. All right. So again, very similar to the steel version. It comes in modules, and typical classroom modules. You see here, that's the corridor, and that's the classroom, and the internal wall and the external wall. So it's as simple as that, and then you assemble them on site. We had to actually get a factory to manufacture this. So in order to reduce transportation, this kind of mobile manufacturing locations would be a great asset to keep it near where your site is. And generally once they've done that, then they lift it and put it in place. Okay. And then you see the modules being transported to the sites. And again, schools are very tight sites because they don't normally have your bomba road that goes around. Somehow we managed to get away with that. And then they were plonked in place. So you can see the foundations are quite interesting because they are actually in a strip, and we lock them down and it sits on a beam, and then that module with the corridor. And when you put them all in a row, it becomes the makings of a school. And we stack them on top of each other to get whether it's 2-story or 3-story. And then the trick was then to fill the joints. And this is where you see that the contractors are actually putting in the screeding to finish it off. There were issues with this because in terms of the final finishing, it's still a labor-based type of construction, so it's not as clean. And the final product looks like that. Typical school. And you wouldn't have been able to tell the difference whether it is in situ or precast. But the biggest thing about it is that we completed it before the school started, so we managed to do it within the 2 months. This is another one. So in all, we actually built 5 schools in 2 months. It's quite an interesting challenge. Okay, 35 classrooms, yeah. So the internal feels a little bit like this. The only slight drawback about this is that you can see the beams for the modules, because each module sits on its own frame. You get more beams within the classroom. So you just got to allow for a higher ceiling. Yeah. So our overall experience of IBS, for sure, quality is much, much, much better. You're able to control the finishing. You're able to control the details. And because they are all off the factory, you have the opportunity to test it out, get it done before it actually hits site. And when it hits site, it's essentially a manufacturing process. Okay. Construction time, definitely much quicker. And you need to pre-plan a lot of things. So a lot of our work is not left to the end during construction and you figure out your details. All your details are all brought right to the front. Yeah, so that there's, you don't wait for site. Site is basically an assembly situation. It's much cleaner on site and it's much safer on site. We have less people on site. And it goes on towards allowing us to manage the site much better. One of the biggest problems that we always continuously face is how contractors look after the site, and the sites are always messy, right? And having the IBS systems contributes a huge amount to the contractors for having to manage less. Yeah, and when we talk about labor efficiency next, due to all those parameters, when you have less people on site, it is always much, much easier. Yeah, you don't have to contend with the presence of labor on site and all their own outputs. You know, they mess up the place, places for them to stay, etc., etc. Yeah, and it also promotes towards a greater skill level for the contractors. You know, not just your usual guy who comes and slaps on some wet works. It needs people who think a little bit more, who is able to put things in the right place. Okay. Cost predictability. We've got almost no rework because everything is already thought through, and material wastage is very minimal. Yeah, and overall it would be much more sustainable. And as I was saying earlier, the challenge that we face in this country, relative to a developed country, is that the costs of labor in the developed countries are very high. And therefore, relative to your IBS system, it's low. But in this country, where we still employ low-cost foreign workers, it pushes that cost of IBS up. So in a sense, the way that our economy is structured, it is actually, we are actually killing ourselves in the long run. You know, you are still low value, low labor cost dependent. You are not actually moving up the scale. So having IBS face this particular challenge is going to be a perennial problem. So it could be a political problem because we just don't want to come up and face this situation. And I guess where we can become a developed country is when we start to change the way we think as a country. You know, it's not an individual or a company issue. It is the fact that contractors will use the lowest cost possible, right? And if we don't maintain that level of skill and income, IBS will always be a challenge. But in terms of its methodology, it's definitely a much more sustainable method of construction. Okay, the downside of IBS. Okay, the one thing that you don't realize is that you're married to them. Okay, and you can only part when you die. Okay, why? Because you are totally dependent on the supplier's production ability. If he produces fast, you get it fast. He produces slow, you get it slow. Right? That's one. Secondly, it's a proprietary system. Halfway down the road, you have a quarrel with the flow, right? And you say, hey, Dewan, we want to part ways. After that, who's going to do your work? It's a proprietary system. You can't fix it. Yeah? And third one, which is probably the most difficult, is their contractual legalism. If the guy sits there and calculates with you every single screw, man, you are screwed. Okay? So you are married to this guy, right? So like a good marriage, you have to select your partners, your marriage partner properly, right? You mess up on any one of these three, you are dead in the water. All right? And you see it, and this is a very challenging thing for us because your first decision impacts everything else. In your conventional system, your first decision is not so important because you think that you can have this option or that option or whatever that you want to do to fix a problem, to get on with it. This one, you're married into your problem. Okay, and there's no exit clause. Die, you got to finish at the end. Okay? And then, of course, the rest of the things are the logistic challenges. And if you notice all the modules, they all have to fit on a truck, especially for the PPVC ones, right? So you don't realize, but you've got to know the height of the bridges, the underpasses to get to your site. You've got to know the length of the truck. You've got to know how many modules. So it constrains you by way of the rigidity of some of these for PPVC. For the prefab one, it's got a little bit more flexibility there. Okay. There's also a front load cost because when you start manufacturing, you got to start paying before you see the building on site, right? And one of the biggest things that we always face is when you go to the factory to verify which is your product, you really can't tell, right? It can be yours, it can be somebody else's, you know, and you go verify and you think, okay, you know, there's 1,000 pieces for me, so you verify 1,000, but the 1,000 may not come to your site. It could have gone to somebody else's site, right? So this depends a lot, again, on the integrity of the manufacturer, who they are, so that you know that these are all bona fide, yeah? As Lee says, there are many manufacturers now, so you got to be really sharp, right, to make sure that these are bona fide people. And generally, it's a higher cost if you go into IBS, prefab systems. But having said that, when we did Taylor's Lakeside campus, we managed to build everything for 160 ringgit per square foot, including the prefab system, including the water, including the highway connection. So it didn't quite cost us more, you know. So it means that you have to balance out how you allocate budgets for the different things. Okay. All right, and one of the things that I like to also ask is the future. Where are we going? And I just want to share with you this project that we did. It's not quite a fully IBS project, but it is something that could affect the paradigm that we look at things. All right. This project is called the New Ocean World. It's in Jalan 19, PJ. And it is a building that contains 20 food outlets with a banquet hall and a cigar bar right at the top. And this is interesting because it encourages us to look at IBS in a slightly different way. The facades and all that are the usual glazing and the screenings. We have got the cigar bar at the top, and the entire roof garden is currently being renovated so that it becomes a happening place. What I want to show you is how we've, let's see, I've got a video that runs. Okay, and we struggle with the unitized glazing contractor. Massive problem we had with them. Okay, and this eventually got built, and the main contractor kindly assisted, and we had to do a lot of work to overcome those problems, right? But what I really wanted to talk about is this: the picture on the left. We introduced a 600 automated car park system with no conventional parking. And what we did was, this 600 car parks took the place of your usual ramp and concrete system. So we've actually eliminated 7 floors of car parks, traditional, conventional concrete, and essentially created this automated system. And how it's recognized in your IBS system, not quite yet. Maybe it could be given more prominence, but certainly by using technology of this nature, we can then look at it's a bit of a paradigm shift in this country. in Japan and Korea is quite a common system, but in Malaysia, not so. But what we found was by eliminating that 7 floors of concrete, number one, we freed up a lot of space. And number two, the volume of in situ construction reduced significantly. Bearing in mind that we were trying to get this off as soon as possible as well. And the great thing about this automated car park system is that floor to floor for the parking is only 2.2 meters each rack. Yeah, and the 7 floors of car parks is actually now pushed down to about 5 physical floors. All right, so that saved us a lot in terms of physical space we have to provide for the car parks. All right, and obviously the typical construction. And the owners have also installed the LED lights onto the facade, and his expression of the ocean, so you see that wave on the facade. And the other interesting thing is, you don't have to go to Singapore now. You can come to PJ. We've got this waterfall thing. So this is actually a digital wall. Okay. And we've got it it's like a 3-story high wall, the entire wall at the back of the lifts.
Now you can do it in Neo General.
And we have some fiber optic lines also.
Yeah, so, and that's the lobby. This is the banquet hall to the project. Okay. And in the banquet hall itself, this is where it gets interesting, because now the walls are used as digital walls. It's a 3-dimensional digital wall. Okay, and they are able now to run a lot of graphics and videos on the wall, and it's actually coordinated with the ceiling as well. So when we look at industrial building systems, these are the new things that's coming into the market. So how do we then recognize them as part of our construction system? Okay, and it's turning walls into media functions, and it just changes the dynamics of space. Right, on that note, thank you very much.
Assalamualaikum and good morning semua. Okay, today my presentation will be in Malay. Everybody okay? Okay, saya Muhammad Shaharil bin Matop, okay, daripada CIDB IBS Sdn Bhd, a subsidiary to CIDB Malaysia. Sepatutnya session selepas rehat kita ada 2 presenter. One is from the CIDB side, Cik Rizal. Okay, tapi dia ada emergency, so saya akan present on behalf of dia punya slide, dan after that saya akan cover sikit untuk CIS 18. Okay, so CIDB punya more to policy lah. I think untuk policy semua orang kena aware lah. So kena aware on the latest policy, on the what the CIDB sekarang ni tengah push the PBT, especially on the IBS. Saya ada 45 minit je. Okay. So kita akan habis awal hari ni, insyaAllah. Okay, sebelum saya mulakan, boleh tak saya tanya, nak tengok crowd, mostly memang daripada architecture punya firm, ataupun ada mix dengan contractor ataupun CNS? Ada contractor ke? Ada CNS ke? Tak ada. Memang mostly daripada architect punya firm. Okay. Architect punya firm kat sini memang saya rasa is a good punya info, knowledge, sebab sekarang CIDB telah dilantik as a ITL. Roughly saya cerita dulu, CIDB telah dilantik sebagai ITL, agensi teknikal luar bersama-sama dengan agensi lain. So di situ berlaku beberapa kewajipan di bawah polisi IBS yang akan saya terangkan sebentar lagi. Kalau ada apa-apa soalan yang mungkin kita tak akan tunggu Q&A, mungkin boleh utarakan. Okey, kita akan cuba jawab. Okey, pertama adalah tujuan mengenai polisi dan keperluan statutory untuk program IBS di Malaysia. Okey, ada pekeliling terbaru iaitu daripada KSU KPKT bilangan 4 pada tahun 2024, iaitu berkenaan pemantauan dan pelaksanaan IBS bagi projek swasta telah dikuatkuasakan bermula 10 Julai 2024. Ada tak yang tak aware? Okey, kalau aware bagus. Bermula Julai 2024, CIDB penguatkuasaan tu adalah datang daripada Pekeliling. So selepas itu CIDB telah mengambil inisiatif untuk membuat tour kepada semua PBT, semua negeri berkenaan dengan pekeliling yang KPKT telah keluarkan. Sehingga terkini cuma ada beberapa PBT yang telah implementkan 100% menggunakan pakai untuk pekeliling KPKT ini. Mesti syarat lulus adalah mesti ada 70 skor IBS. Sekiranya permohonan pelan bangunan tidak mencapai 70, so PBT akan automatik gagal lah. Masuk OSC akan gagal. Okay, nanti saya akan explain lebih detail. Kalau kita tengok di situ terdapat Akta LPIM 1994 di bawah Akta 520 CIDB di bawah pindaan 2011, iaitu pekerja binaan mahir dan kompetensi kemahiran pembinaan untuk SKKP dan perlakuan pematuhan standard PPS juga telah diimplement untuk projek-projek site. Mungkin tadi session pertama daripada Premarin memang very aware dengan CIDB punya rule dan juga PPS punya program. So sepatutnya mereka aware lah. Sebenarnya biasanya hanya terkait untuk kontraktor. As architect, session yang ini polisi adalah lebih kepada architect punya part lah. Okay. Lepas tu kita ada peraturan pendaftaran kontraktor industri, iaitu industri pembinaan semasa perkeluaran pendaftaran, iaitu PPK. PPK saya rasa semua orang tahulah, tak ada masalah. Okey, di depan ni kita boleh nampak adalah pekeliling KSU KPKT bilangan 4 yang telah ditandatangani oleh Datuk Wira Muhammad Noor Azam. Yang ini bertarikh tadi Jun 2024. Sekarang dah almost Jun, dah almost tahun. KPI CIDB diletakkan, kalau kita boleh nampak kat sini, ada sekurang-kurangnya semua PBT, 50% PBT mesti dah implement pada tahun 2025. Sekarang CIDB tengah push semua PBT termasuk Sabah dan Sarawak. Sabah Sarawak pun kita dah masuk, CIDB dah masuk. Semenanjung terutamanya PBT contoh macam Kelantan, Ipoh, ada yang dah implement dan juga Perlis. Coming soon mungkin PBT yang besar contoh macam di BKL, area Lembah Kelang lah yang akan implement. Dan sebab kenapa mereka delay, sebab mereka kena tengok overall in term of the system. Dia bukan simply dia boleh implement sebab projek yang Lembah Kelang, projek bernilai 50 juta ke atas tu banyak. So ada impact kat internal dia orang punya team. Okay, nanti saya akan explain lebih detail. Okay, untuk polisi pelaksanaan IBS ini, polisi sedia ada, iaitu sebelum pekeliling terbaru keluar, projek menilai 50 juta dan ke atas dan mempunyai keluasan lantai sekurang-kurangnya GFA 50,000 meter square sahaja. Itu yang sebelum. Yang terbaru skor adalah 70 skor IBS, terbaru 70 dan juga GFA adalah sama 50 meter persegi. Tambahan CIDB adalah agensi pemantau dan pihak berwajib yang memberikan pengecualian. Bermaksud di sini CIDB yang akan memberi pengesahan untuk IBS score. Semua IBS score sebelum disubmit kepada PBT mesti melalui CIDB, iaitu ada satu sistem ISCS yang akan saya tunjukkan sebentar lagi. Semua PSP mesti menghantar pengiraan scoring untuk mendapatkan 70. Sekiranya mendapat 70 baru boleh dibawa untuk mendapatkan kelulusan kepada PBT. Sekiranya tak dapat 70, kalau you bawa masuk juga ke PBT, nanti di OAC dia akan gagal lah syarat OAC. Okay, kena ulang balik. So kalau gagal, saya nasihatkan jangan hantar terus submit untuk PBT. untuk kelulusan pelan bangunan. Okay, kat sini kita boleh nampak polisi 2017 dan polisi terkini. Kat sini saya rasa step forward. Perbezaannya adalah 50 skor pada yang lepas, 70 skor adalah yang terbaru, dan juga rujukan CIS yang terbaru adalah rujukan CIS 2023. Kita tidak refer dari CIS 2018 ataupun 2010. So semua pengiraan adalah berdasarkan CIS 2023. Okay. Yang ini sebenarnya pun PSP terutamanya arkitek kena aware lah, sebab sekiranya you calculate based on daripada 2018 nya last version, dan nanti kita assume you dah dapat calculate 75 ataupun 80, tapi bila you submit rupanya you salah reference, you pakai yang last version, later version you tak dapat 70 pun, then tough lah untuk arkitek. You kena redo balik, you kena recalculate balik, you kena convert a few things untuk dapatkan minimum 70 tu semula lah. Okay, so reference kena berhati-hati kat sini ya. Sebab sekarang dah wajib, dia lain sikit. Dulu tak wajib, tak ada isu. Bagi saya tak ada isu. Up to client. Kalau klien kata 70, you refer, you pakai CIS 2018, klien kata proceed. Sekarang ni dia dah di bawah PBT, kelulusan pelan bangunan. Klien pun terpaksa ikut, especially dalam PSP pun terpaksa ikutlah, sebab kalau tak you tak akan dapat kelulusan pelan bangunan. Okay. Kita tengok balik overall apa yang penting, saya rasa tak ada apa, refer back seperti yang saya cakap tadi. Okay, 70 skor IBS sekarang ni memang 70, tak ada dah 50 untuk private swasta, 70, dan juga projek bernilai 50 juta ke atas dengan keluasan lantai 50,000 meter persegi ke atas. Okay, itu saja. Dan juga pekeliling tu saya ulang semula, CIDB adalah sekarang ni sebagai ITL. CIDB bukan hanya membuat penilaian untuk scoring, tetapi kita juga akan membuat lawatan di tapak. Di lawatan di tapak kita akan buat, kita dah berbincang dengan OSC KPKT. Kita akan buat penilaian pada in between 40 ke 60 progress untuk melihat apa yang dihantar, calculation untuk IBS 70 tu maknanya diimplement di tapak seperti yang disubmit lah. Sekiranya terdapat perubahan yang major, so kita CIDB akan mengeluarkan satu kenyataan lah nanti, statement, kontraktor kena menjawab lah perubahan tu. Maknanya tidak follow seperti apa yang telah disubmit pada awal-awal semasa kelulusan pembangunan. Okay. Kalau ada nak tanya, boleh terus tanya. Takut dah lupa nanti lepas ni. Okay. Berdasarkan daripada pekeliling yang terbaru tu, CIDB telah mengeluarkan satu panduan. Okay. Kita panggil garis panduan pemantauan. Itu untuk CIDB dan juga untuk PSP, untuk rujukan juga lah, sebab dia very complicated benda tu. Tak sangat complicated. Maksud saya untuk rujukan PSP, apa sebenarnya yang CIDB punya portion yang boleh kita sharing lah. Okay, untuk pemantauan dan pelaksanaan penggunaan kaedah IBS sebagai syarat wajib dalam permohonan pelan bangunan ni, di dalam kita punya panduan pemantauan tu, saya tak bawa hari ni, tapi kalau ada yang PSP yang nak, nanti kena apply lah, kena mohon kepada CIDB. Okey, di dalam pelaksanaan penggunaan pemantauan tu, kita ada kriteria yang mewajibkan pelaksanaan penggunaan kaedah IBS. Okey, kita dah garis panduan tu, kita dah complete, kita dah work out, kita dah printed dah, dan juga mungkin boleh tengok sendiri. Itu ada juga pengecualian pelaksanaan kaedah IBS. Maksudnya still ada pengecualian, nanti saya akan explain, tetapi pengecualian hanya ada dua alasan sajalah. Okey. Alasan-alasan lain tu memang susah sikit lah, kecuali benda yang beyond kita punya ni lah. Okay. Kedua, mekanisme pelaksanaan kaedah IBS dan juga penetapan garis panduan pelaksanaan polisi IBS bagi projek swasta. So di dalam garis panduan seperti yang kita tengok sebelah kanan tu juga adalah di dalam lampiran tu ada mekanisme pelaksanaan kaedah IBS, permohonan, macam mana nak buat permohonan dengan PBT dan semualah berkaitan. Okey, untuk setiap PBT kemungkinan dia akan berbeza-beza sedikit. Bagi PBT yang follow OSC 3+, tak ada masalah, memang kita dah tap dengan OSC 3+. Tetapi bagi PBT yang tidak menggunakan sistem OSC 3+, macam di BKL, so yang itu totally lain sikit. So di BKL, mereka ada sistem mereka sendiri. Dia tak follow OSC 3+. Sama juga seperti di Sabah dan Sarawak. Sabah dan Sarawak juga tidak menggunakan OSC 3+ lah. So mereka ada sistem mereka sendiri. Kemungkinan kalau mereka implement, mereka akan go manual. Itu terpulang kepada PBT, mengikut PBT. Okay, saya sambung semula. Manual pengguna, kandungan di dalam manual pengguna tu kita dah simplify. Kita boleh nampak kat sini dia ada beberapa proses, antaranya proses pertama, proses kedua, proses ketiga dan proses keempat. Okey, tuan-tuan boleh tengok. Okey, proses pertama permohonan dan pengesahan skor IBS. Permohonan pengecualian IBS adalah berada pada proses pertama. Ya, ini sistem OSC 3+ tidak akan mengena. Okey, ia adalah di bawah sistem CDB sendiri, iaitu ISCS, kita panggil ISCS. Selepas tu kita ada manual untuk proses pertimbangan pelan pemaju, yang di mana adalah permohonan pengesahan skor IBS, pindaan pelan, jika lulus dengan pindaan pelan, semua ada kat dalam tu. Semua kriteria sama ada lulus, kena ada pindaan, semua kita dah masukkan kat dalam tu. Okay, kita boleh tengok kat sini pengembukaan surat pengesahan skor IBS dan surat keputusan pengecualian IBS, pembukaan surat pengesahan skor IBS dan pindaan pelan jika lulus dengan pindaan pelan. Jika lulus dengan pindaan pelan ni maksudnya di dalam OAC 3+ tu lulus tapi dengan pindaan pelan. Okey. So, kita boleh tengoklah. Lepas tu ada notifikasi mula kerja. Notifikasi mula kerja ni adalah juga di bawah peringkat OAC. Dalam OAC memang ada. Okey. Memang dah ada dalam dia punya sistem. Lepas tu proses keempat, pemantauan tapak bina dan notifikasi pemeriksaan interim. Okey, yang ini adalah notifikasi kemajuan struktur bangunan projek IBS. Saya rasa yang ini nanti tuan-tuan kalau ni nak lebih detail boleh tengok sini dalam garis panduan tu. Garis panduan tu boleh dapatkan daripada CIDB. Okey, ini adalah website yang telah dibangunkan oleh CIDB. Kita panggil iscs.cidb.gov.my. Okey, proses fee untuk pendaftaran adalah 200. Hanya PSP yang mempunyai kita panggil AR lah yang boleh daftar. Pendaftaran ni bukan untuk macam staff, mungkin tolong boleh on behalf of, kalau satu company tu dia ada 2 AR. Okey, AR tu yang kena daftar kat sinilah, kat dalam ni. So sebab dia represent AR tu punya capacity semasa membuat submission. Kalau manual form sebelum ni, AR hanya akan endorse saja. AR ataupun IR endorse saja form calculation untuk IBS. Tapi bila di dalam sistem kita CIDB rasa macam complicated benda tu bila you nak endorse, lepas tu you nak scan, lepas tu you nak upload. So untuk yang gini AR dan mungkin CNS juga boleh daftar sahaja. So boleh pakailah mungkin staff ataupun arkitek bawah boleh tolong bantu uploadkan semua dokumen-dokumen keperluan untuk kelulusan. Okay. Yang tuan-tuan nampak kat sini, inilah website-nya. Nanti boleh masuk, boleh tengok. Cuma dekat sini, kalau tuan-tuan nampak kat atas ni ada IBS score calculator for free saja. For free, maksudnya kalau yang 50-50 calculate dah. Tiba-tiba rasa betul ke dapat 70, ngam-ngam 72, ngam-ngam kira-kira dapat 73. Ngam saja kan. So, boleh cuba pakai ni. Kalau key in dapat 72, betul lah tu. Key in dapat 65, banyak nak tengok balik. Okay. Sebelum daftar sebenarnya boleh pakai ni calculator ni. Calculator ni memang dah ada dalam website ni. Siapa-siapa boleh pakai. Tapi memang berguna untuk arkitek lah. Saya rasa memang arkitek lah. First step. Lepas tu mungkin CNS lah. CNS saya rasa berkait juga sebenarnya. Both party memang berkait. Tapi arkitek dah boleh tengok-tengok dulu. Pakai sistem pun nak pakai kolom ke, nak pakai sistem apa kan. So boleh tengok kat sini. So memang sebenarnya kalau in term of kejap lagi saya cerita pasal CS 18, kalau paling high rank punya scoring memang IBS lah. Applikas. Kalau you pakai Applikas tak payah risau lah, 90, 100 pun boleh dapat. 95, 96, 97 memang tak ada isu. Tapi bila you pakai sistem lain, tu je, tricky. Nak dapat 70 pun kadang-kadang susah. Bila nak dapat 70 tu susah tu, memang kena bincang betul-betul lah dengan klien. Nak achieve 70 tu, kalau rasa dah 50-50 nak dapat 70, it's good kalau you terus mix. Either you mix sistem, Applikas dan juga sistem lain untuk you dapat skor tinggi. Mungkin slab you pakai Applikas, benda-benda macam tu mix, baru boleh dapat skor tinggi. Kalau solely one system, let's say pakai formwork system, memang susah. Baru 0.4. Baru 0.4, kalau 100% memang you tak akan dapat lah. Baru 50 plus je dapat. So that's why kena mix. Nanti saya akan explain untuk part CIS 18. Okay, ini website dia. Okay, lepas tu di dalam mekanisme pelaksanaan kita boleh nampak, okay, dia straightforward. Saya rasa straightforward. Pertama adalah penyerahan pelan bangunan. Kedua, pengesahan IBS score. Ketiga, semakkan dan ulasan teknikal, itu part CIDB lah. Dan lawatan tapak seperti saya cakap tadi, in between 40 hingga 60 progress. Dan sama ada tindakan ketidakpatuhan. Tindakan kepatuhan ni lebih kepada pemakluman kepada BUT berkenaan lembaga profesional yang berkait lah. Kita punya keliling ni, dia tak sampai CCC. InsyaAllah dia tak sampai CCC, dia tak terkait pun dengan CCC. So CCC boleh proceed je. Tetapi apa tindakan yang CIDB boleh ambil setakat ini lebih kepada ni sajalah. Kita akan maklum kepada PBT dan juga KPKT berkenaan dengan mungkin nama arkitek, nama kontraktor yang mungkin ada problem lah maksudnya, dan juga kepada lembaga profesional. Lembaga profesional tu mungkin kepada PAM lah. Okay, itu saja yang tindakan setakat ni yang CIDB boleh ambil lah. Okay, kita tak sampai sisi-sisi kelulusan tu tiada kena mengena dengan kita punya program ni. PEKELILING ni. Okay, tuan-tuan boleh tengok roughly lebih kurang macam ni saja. Maksudnya PEKELILING KSU KPKT itu berkait dengan permohonan, pengesahan, perakuan dan pemantauan penguatkuasaan. Kat sini kita boleh nampaklah lebih kurang permohonan, ke atasnya OAC, Jabatan Perancangan PBT, inilah kelulusan KM. Kelulusan KM kita tak ada kena mengena. Lepas tu kelulusan permohonan PBT untuk pelan bangunan. Di sini nanti fungsi CIDB akan wujudlah. Semasa CIDB adalah agensi teknik keluaran, kat sini nanti sebelum membuat kelulusan permohonan untuk pelan bangunan, kat sini nanti kena dapatkan dulu scoring. Selepas dah dapat scoring, baru you boleh gunakan attachment tu untuk membuat submission bersama dengan kelulusan pelan bangunan bahagian sini. Baru boleh masuk ke jawatankuasa OAC. CIDB juga akan hadir mesyuarat tu juga nanti untuk memberi maklum malas bersama sekiranya diperlukan. Ada apa-apa pertanyaan ke? Teruskan Okey. Kalau kita tengok di sini, ini adalah lebih kurang dia punya flow. Okey. Penglibatan ISCS di mana penglibatan sistem OSC 3+, di mana menggunakan sistem 3+ ni, saya rasa dah familiar lah dengan OSC 3+, di mana pelibatan semula untuk sistem ISCS. Sekarang ni kita memang cuba tap kita punya sistem ISCS ni dengan OSC 3+, tapi tak semua kita boleh tap. Okay, memang ada limitation. So tak apalah, itu concurrent kita akan berbincang dengan KPKT lah untuk dia punya sistem. Di mana OSC ISCS ni dia ada permulaan awal-awal lagi. Maksudnya maklumat teknikal kena disubmit dalam ISCS. Semua drawing, semua calculation, proof architect drawing, CNS, apa-apa yang berkait IBS punya sistem. So you submit, so kita akan buat penilaian dan kita akan keluarkan scoring. Scoring yang kita keluarkan tu, pengesahan tu nanti baru you boleh guna untuk sistem OSC 3+ untuk mendapatkan permohonan pelan bangunan seperti yang saya cakap tadi lah. So ini dia punya flow. Sama ada lulus dengan pindaan, naik balik lah. Lulus dengan pindaan, naik balik. Kalau lulus, terus pergi ke sistem OSC seterusnya lah untuk kelulusan. Okay, kalau tolak, kena tengok balik. Macam saya cakap tadi, tolak sebab biasanya tolak ni sebab scoring tu kurang lah. Scoring kurang. Tetapi sepatutnya kalau you dah dapat dah kita punya result ni bawah 70, jangan submit lah. Confirm kena tolak. PBT mesti tolak. Tak tahulah kalau nak cuba submit, kadang-kadang mungkin ada yang nak cuba juga submit kan. Saya rasa PBT akan tolak juga, reject. So bila reject, kena buat balik, kena tengok balik, kena discuss balik sistem apa yang patut dan calculate balik, dan baru dia submit di atas semula dan kita akan turun balik ikut flow lah. Okay. Penglibatan CIDB kebanyakan memang dekat pengesahan skor IBS saja, dan juga nanti akan ada pemeriksaan tapak bina, pemantauan tapak bina. Okey. Ini lebih kurang detail sikit dengan dia punya mekanisme pelaksanaan seperti yang saya tunjuk tadi. Saya roughly saja cerita serba sedikit seperti apa yang saya dah sampaikan kepada tuan-tuan dan puan-puan. Iaitu pertama adalah membuat pengiraan skor. Ini merujuk kepada CIS 18 yang terbaru, iaitu 2024 yang terbaru sekali 2024. 2024 ni ada banyak perubahan juga, nanti saya tunjukkan juga. In term of scoring, pengurangan dia punya multiple score, semua ada banyak perubahan. So sebelum ni kalau pakai sistem formwork mungkin boleh dapat skor agak tinggi. Sekarang ni agak kurang. Bukanlah kita nak drop sistem tu, tetapi kena mix dengan sistem-sistem lain. Lepas tu cas pemprosesan, kalau kita tengok dekat item nombor 2, cas pemprosesan dikenakan adalah sebanyak RM200 per permohonan. Okey, tak tinggi, insya-Allah. Itu as per kelulusan daripada pihak CIDB sendirilah. Dan orang yang berkelayakan perlu melengkapkan borang B, mula kerja tanah dan kerja bangunan. Ini di bawah sistem OAC 3+ lah. Okey, seterusnya CIDB akan menerima surat iringan dengan rekod notifikasi mula kerja binaan berserta dengan dokumen melalui sistem OAC 3+. Ini saya cakap tadi, kita memang dah tap dengan OAC 3+, so kita akan trigger juga apa-apa update. You update dekat sistem OAC 3+, kita akan dapat juga tahu. CIDB akan tahu juga. So di situ nanti kita akan buat pemantauan. Sama ada kita akan masuk tanpa pemakluman, kita dah tahu contoh you dah update dalam OAC 3+, mungkin dah ada progress in between 40 hingga 60, so kita akan set, kita akan pergi tengok sajalah. Kita akan pergi tengok in term of sistem IBS, kita tak tengok lain. Maksudnya kita compare dengan form yang you submit pada awal-awal, sistem apa you pakai, scoring you berapa, kita tengok, kita justify. Kalau you pakai aplikasi lah. Kalau pakai form itu saja kita akan tengok. Kalau kita dapati tidak berlaku ketidakpatuhan, berlaku perubahan selepas daripada you submit tu, contohlah mungkin submit pakai sistem lain, tiba-tiba sampai site dan nak jalan tukar sistem. Sebab itu mungkin up to klien punya approval ke, up to ni punya approval ke, saya tak tahu. Mungkin kalau berlaku lah. Kalau tak, saya rasa jarang berlaku. Tapi kalau berlakunya tu kita akan maklumkan kepada ni lah, kita tak boleh ambil tindakan seperti saya cakap, tapi kita akan maklumkan kepada agensi yang berkaitan. Okey, seterusnya CIDB akan melaksanakan audit tadi pelaksanaan IBS terhadap pematuhan tu, yang itu lebih kepada lawatan tapak dan juga yang ini tadi surat perakuan pematuhan skor. Kini adalah surat terakhir. Sekiranya selepas lawatan kita dapati semua tak ada masalah, sukses, kita akan keluarkan surat perakuan pematuhan skor kepada dalam sistem nanti. Okey. Data-data ni semua adalah data yang kita akan compile dan kita akan submit kepada KPKT untuk menjawab kepada pekeliling itulah. So setiap tahun KPKT akan memantau CIDB progress macam mana PBT, berapa PBT dah implement, dan mungkin start pada tahun 2006 dan 2007 dia akan start monitor berapa projek-projek yang telah mengikut pekeliling ni, dan sekiranya ada masalah apa isu-isunya lah. Okay, pemantauan tu akan start tahun ke tahun lah. Tapi kita mungkin government mungkin belum push terlalu kuat lagi. So this year target pun 50% sahaja PBT untuk implement. Mungkin next year baru target 100% lah untuk semua PBT. Sebab kita faham PBT ni dia lain sikit. Dia ada their own power. So kita kena slowly, kita kena brief mereka dan dengan bantuan KPKT jugalah, insyaAllah. Kalau kita tengok kat sini, bagi benda ni lebih kurang je seperti yang saya cakap tadi. CIDB sekarang ni di sinilah lebih kurang. Kita dah bersama-sama dengan agensi teknikal luar yang lain. Okay. Sebenarnya keberadaan CIDB sebagai ini teknikal luar ni bukannya kehendak CIDB. Sebenarnya adalah kehendak daripada kementerian pihak atasan sendiri. Mungkin disebabkan sebelum ni ada isu-isu yang berbangkit. So mereka yang mengarahkan CIDB menjadi ATL untuk memantau projek-projek IBS. Okay. Kat sini kita boleh tengok semualah JPS, JKR, TMB, apa-apa semua, IC, IWK, semua memang dah ada, memang dah selama ni memang dah lama lah. Kita tengok detail sikit tuan-tuan. Lebih kurang untuk proses. Untuk proses, saya rasa saya takkan cerita terlalu detail lah. Untuk proses overall, kalau tak ada isu, tak ada problem, 19 hari. Maksimum 19 hari. Maksimum. Maksudnya daripada you submit, paling cepat saya rasa mungkin 2-3 hari dah boleh settle kalau tak ada isu. Tapi kalau ada isu, maksimum dokumen tak ada masalah, 19 hari. Dan sekiranya dokumen kena dilihat semula, kena di-redo balik, maksimum kat sini tak ada, adalah 64 hari. Total 64 hari. Kat sinilah berlakunya permohonan, semualah semakan dokumen, terima notifikasi permohonan. Ini semua yang untuk manual pengguna yang boleh digunakan untuk referen nanti. Mungkin sebelum ni direct kepada PBT untuk pelan bangunan, PSP dah tahu dah ada estimate mungkin 2 minggu, mungkin 3 minggu dah boleh settle. Tapi because of ni ada additional masa, ada additional masa yang you kena consider. So you kena awalkan sikit lah sebelum you boleh proceed untuk kelulusan pelan bangunan. kat sini juga tuan-tuan boleh tengok fungsi CIDB iaitu agensi mengulas, termasuk CIDB lah. Kat sini semua agensi akan mengulas kat part ni. Semua agensi. Saya rasa semua maklum kan, semua agensi termasuk CIDB. Kat sini lah akan berlakunya ulasan teknikal, termasuk CIDB punya part ulasan teknikal, sama ada you mencapai pematuhan mencapai 70 skor atau tidak mencapai 70 skor, kita akan buat pematuhan. Kita akan buat ulasan teknikal, dan ulasan teknikal ni akan digunakan pakai untuk mesyuarat OAC lah. So OAC nanti bersidang, kalau tak patuh maksudnya dia akan naik balik lah, dia akan tidak mendapat kelulusan. Okay. Saya rasa hari ni saya tak nak cerita sangat sebenarnya in term of terlalu detail ni, sebab dia agak complicated. Dia agak complicated, bagi orang yang baru dia agak complicated. Tapi tak apa, ini on behalf of seorang lagi presenter. Okay, dia tak dapat hadiah ini, so saya backup dia sikit. Ini pun sama, kita nampak kat sini lebih kurang kalau permohonan kelulusan orang OAC lulus dengan pindaan macam mana dia punya flow. Kalau kat sini kita tengok terima pemakluman pindaan pelan, kemuka dokumen pindaan pelan, kat sini ada 14 hari. Okay, inilah lebih kurang dia punya flow di dalam manual pengguna. Dalam manual pengguna ni sebenarnya tuan-tuan boleh tengok dekat dalam buku panduan pengguna yang CIDB keluarkan tu, kita dah complete kat dalam tu. So boleh jadikan sebagai rujukan nanti tuan-tuan puan-puan. Yang ini juga sama, di mana untuk borang B, untuk borang B, di mana di sinilah CIDB punya keberadaan, okay. Dan juga selepas daripada lalai agensi ni, di sinilah OAC dan agensi pemantau tapak bina, seperti yang saya cakap tadi tuan-tuan puan-puan. Juga sama, lebih kurang, okay, di mana adalah proses keempat. Ini adalah proses keempat di mana pemantauan tapak bina dan notifikasi pemeriksaan interim berlaku, okay, bersama-sama dengan TMB, JKKP, AWK, di mana semua agensi ini akan melakukan pemantauan tapak. Tapi CIDB kita lebih kepada tengok scoring. Agensi lain mungkin dia orang punya SOP adalah berlainan. Semua di bawah OAC dan agensi lain tuan-tuan. Okey ke tuan-tuan? Saya teruskan. Ini memang banyak sikit workflow, sebab yang ini workflow ni sebenarnya penting kepada semua, terutama PSP dan juga CNS. Tapi kalau kita nak capture, nak faham semua hari ni, saya rasa memang susah sikit sebab dia memang agak complicated. That's why saya cakap tadi, boleh dapatkan buku manual pengguna daripada CIDB, kita boleh study betul-betul, kita boleh tengok betul-betul apa step-step dia, apa yang perlu dipahamkan dan apakah tindakan-tindakan yang diambil oleh CIDB yang kena dimaklumkan lah. Okay. So kat sini kita boleh tengok kalau untuk proses IBS bagi proses swasta, tu manual pengguna ni tadi, PSP perlu mengemaskini progres di tapak bina di dalam sistem ICS. Yang ini tadi maknanya dah dapat kelulusan, lepas tu nanti PSP kena update dalam sistem ICS tu untuk progres di tapak. Baru kita akan maklum, baru kita akan datang ke tapak bina lah. Ini semua akan ada dalam sistem ICS tu nanti, dia akan trigger sendiri dan PSP kena isi lah nanti semasa selepas mendapat kelulusan. So lebih kurang macam dia punya proses. Sistem ICS akan memberi notifikasi kepada pegawai CIDB negeri, di mana CIDB negeri ada di semua tempat insyaAllah. So mereka yang akan turun ke tapak bersama-sama dengan HQ lah nanti untuk membuat pemantauan. So di sini nanti akan berlaku pemeriksaan sama ada berlaku ketidakpatuhan ataupun semua berjalan dengan lancar lah. Okay. Kalau kita tengok untuk pengecualian pelaksanaan IBS hanya ada dua sahaja, iaitu bagi projek pengubahsuaian bangunan sedia ada dan tidak melibatkan pembinaan bangunan baharu. Yang pertama. Kedua adalah projek penyiapan kerja yang terbengkalai, yang asalnya tidak dilaksanakan secara kaedah IBS. Setakat ni hanya dua sahaja projek yang boleh mendapatkan pengecualian. Contohlah mengikut kriteria 50 juta ke atas, 50,000 meter persegi tadi, projek tu dah wajib. Kita dah wajib untuk menggunakan sistem IBS. Tetapi sekiranya projek ini di bawah projek pengesuaian dan juga projek terbengkalai, you boleh terus mohon tadi, tak perlu hantar untuk pengesahan IBS score, terus minta pengecualian. Terus minta pengecualian bagi justification, so CIDB akan mengeluarkan pengecualian sekiranya straightforward berdasarkan dua item ni lah. Tapi sekiranya memohon pengecualian sebab-sebab lain, kadang-kadang banyak sebab. Banyak sebab supplier tak ada. Kalau kita tengok JKR punya projek banyak pengecualian. Walaupun dah wajib, kita tahu wajib, tapi banyak je kontraktor yang mohon pengecualian di bawah JKR. Pengecualian tu adalah sebab-sebab dia. Supplier tak ada, supplier tak boleh commit. Sepatutnya dah nak start lagi 3 bulan, supplier kata setahun baru boleh supply. So antara tu alasan-alasan which is mungkin swasta pun, untuk projek swasta pun kita akan menerima lah nanti. Tapi benda tu sepatutnya tidak akan diberi kelulusan, tapi bergantung. Okay. Okay. Ini sini lebih kurang kepada manual pengguna untuk pengecualian pelaksanaan. Untuk pengecualian pelaksanaan ni daripada atas lagi memang dah boleh mohon terus untuk pengecualian, dan dah juga disertakan bersama dengan lukisan arkitek, lukisan struktur dan lukisan-lukisan lain yang berkaitan lah. Mungkin dah dapat kelulusan daripada kebenaran merancang, masukkan sekali, attest sekali, dan baru kita akan proses. Kita akan proses, dan proses maksimum adalah selama 45 hari. Okay, yang untuk pengecualian dia memerlukan kelulusan di peringkat atasan teratas CIDB, iaitu Ketua Eksekutif. Ketua Eksekutif CIDB, KE, akan bersidang di bawah satu jawatankuasa untuk memberikan kelulusan bagi pengecualian-pengecualian yang dimohon oleh pihak swasta. Okay. Kita dah habis dapat yang ATL tu. Okay, ATL tu dia memang benda baru, tetapi kita industri kena terpaksa ikut lah sebab dah diwajibkan. Sebelum ni private sector dah wajib since saya rasa 2008, dah lama dah, 2008 sekarang mungkin dah almost berapa belas tahun. Private sector, government sector dah wajib untuk IBS, baru last year baru start untuk private sector. Okay, kat sini kita boleh tengok statistik bekal IBS, berkait sikit. Maksudnya seperti yang saya cakap tadi, bila dah wajib, sekarang ni kita tengok jumlah pembekal ada 100 lebih sahaja. 100 lebih sahaja, tak banyak sebenarnya. So kita harap dengan PEKELILING terbaru ni, jumlah untuk pembekal akan meningkat. Ini akan membantu sebenarnya industri. Okay. Kalau kita tengok kat sini, Johor total, Johor banyak lah sebab Johor banyak supply to Johor dan juga supply to Singapore. Tapi kebanyakan yang supply to Singapore tu, dia tak daftar pun bawah Malaysia government ataupun bawah CIDB sebab tak ada keperluan. Dia bukan supply projek Malaysia, dia hanya tumpang tempat untuk buat casting sahaja dan dia terus export ke Singapore. So benda tu CIDB tak ada kena-mengena lah. As long as sebab kalau dia memang supply to Malaysia, dia kena apply PPS, CIS24. Itu adalah antara benda-benda CJ yang mereka kena patuhi lah. Kalau kat sini kita tengok yang paling banyak adalah di Selangor. Selangor nombor 2 adalah di Negeri Sembilan di Senawang, dan juga yang lain-lain lah. Yang lain-lain Terengganu, semua boleh pesan ke Kuala Lumpur memang tak ada langsung, ada satu, dan juga Perlis pun tak ada. So kat sini boleh jadikan rujukan juga untuk tuan-tuan dan perempuan semasa membuat pemilihan sistem tu nanti. Tuan-tuan boleh tengok supplier nak ambil daripada mana. Supplier tu ada ke tak ada kat kawasan pembangunan tuan-tuan tu. Kalau tuan-tuan punya projek tu memang ada KL, Selangor, saya rasa tak ada masalah. Memang tuan-tuan boleh pilih je. Tapi kalau perempuan punya projek tu di kawasan yang contoh Labuan, dah nampak lah ni isunya adalah pembekal tak ada nanti. So tak ada siapa yang boleh supply kecuali memang ada dah manufacturer yang boleh commit, boleh hantar material terus untuk tuan-tuan punya projek lah. Sebab dah wajib, nak tak nak kena guna. Kalau tak guna kena minta pengecualian, kalau dapat pengecualian. Kalau tak dapat pengecualian, kena juga fikir macam mana nak start projek lah. Okay. Ini adalah peta taburan pembekal IBS yang aktif. Lebih kurang ini untuk makluman tuan-tuan dan puan-puan saja. Okay, kalau kita tengok ini adalah sistem inovatif, sistem konkrit peratuang, sistem acuan berulang, formwork system, sistem blockwork, sistem kerangka kayu, which is kerangka kayu tidak banyak diguna pakai di Malaysia tuan-tuan. Dan juga sistem kerangka keluli. Agak semakin popular sekarang ni adalah sistem kerangka keluli untuk housing. Housing sekarang ni saya tengok banyak dah menggunakan pakai sistem kerangka keluli. Okay, instead of pakai precast. Okay. Ini lebih kurang roughly lah seperti merujuk kepada carta yang tadi. Okay, rumusan keseluruhan untuk yang ini slide tadi adalah PBT mensyaratkan polisi IBS dalam permohonan untuk kelulusan pelan bangunan. Kelulusan pelan bangunan tuan-tuan, saya memang faham KM mungkin satu permohonan, lepas tu kelulusan pelan bangunan mungkin akan pecah-pecah. Tak dinafikan memang terjadi, banyak je klien yang buat macam tu sebab nak kecil-kecilkan. Pelan bangunan nak jadi kecil-kecil, mungkin nak elak bayar levy, kadang-kadang nak elak jadi wajib. Itu kita tak boleh nak kontrol lah, kita tak boleh nak kontrol. Sebab dalam kadang-kadang dalam kelulusan pelan bangunan besar projek 50 juta ke atas, 50,000 meter square ke atas, tapi bila come to kelulusan pelan bangunan dia dah pecah kecil-kecil, lah. Okay. Itu saya rasa mungkin akan terjadi, tak dinafikan, tapi bukan kami tidak ambil apa-apa inilah tindakan. CDB yang kedua rumusan adalah CDB sekarang ni adalah sebagai ATL, Agensi Teknik Keluaran terbaru yang telah dipertanggungjawabkan oleh pihak kerajaan. Okay, bagi penggunaan kaedah IBS. Dan rumusan yang ketiga, panduan pelaksanaan IBS bagi projek swasta juga adalah berdasarkan pada mekanisme serta tata cara pemantauan dan penguasaan yang telah dikemas kini oleh pihak berkuasa negeri PBN dan juga pihak berkuasa tempatan dan juga pihak berkepentingan. Ini rumusan overall untuk saya punya slide yang baru saya terangkan tadi. Dekat sini kita dapati terutama kalau kat sini memang kita faham semuanya adalah lebih kurang untuk PSP, untuk arkitek. So kita ada dapat juga banyak permohonan arkitek untuk join kita punya program latihan CIS 18. Since CIS 18 ni baru saja diwajib, bukan diimplementkan, yang terbaru CIS 18 2024. Sebelum ni version CIS 18 2018. Totally lain, dia punya scoring pun lain. So dia punya formula pun dah ada perubahan sikit-sikit. Tapi sekejap lagi saya akan explain untuk next saya punya slide. So untuk part yang ini ada apa-apa pertanyaan? So kita akan move kepada next slide, iaitu CIS 18. Okay. Untuk CIS 18, saya rasa arkitek mesti dah tahu lah. Most arkitek mesti dah tahu. CIS 18 ni sebenarnya kita dah mula awal pada tahun berapa, 2003 lagi dah start. So ada beberapa version kat sini. Kita ada CIS 18 tadi 2010, 2018, paling later 2018 di sini. Okay. Kita ada 2010. So in between ni kita ada roadmap 2003-2010. Lepas tu kita ada Construction Industry Master Plan 2006 sampai 2015. Okay, yang ini adalah semua adalah CIDB punya roadmap dan juga semua berkaitan untuk IBS. Okay, berkaitan dengan IBS. Macam mana CIDB punya push untuk industri dan juga untuk government. Sehinggalah yang terbaru adalah CIS 18 2023 yang terbaru itu guna pakai untuk kelulusan ATL. Merujuk kepada tadi punya carta, kita dapati pada 2003 ni roadmap yang IBS mula-mula tadi adalah pada tahun 2010. Okay, lepas tu diikuti dengan 2008 pekeliling baru, pekeliling yang pertama, bilangan 7 2008. Lepas tu pada 2011 ada roadmap 2011-2015 sehinggalah 2024 pekeliling yang terbaru bilangan 4 yang seperti yang saya nyatakan tadi untuk private sector. Okay. So definition IBS ni, since saya faham tadi presenter pertama cerita pasal IBS, tapi saya nak cerita juga sikit sebab CIS 18 ni dia berkait dengan memang IBS. So the definition of IBS ni memang is a technique, a method of building construction tu, which is the product that consists of component precast, the element, the system produced by the manufacturer in a control environment, meaning macam di dalam factory, cast di dalam factory, bukan di dalam factory saja, site casting, itu semua dalam control environment, either on site or off site, and subsequently transported and position, masuk pasang, hantar, terus pasang, terus install, tak ada stacking and assemble into construction work. Itu di bawah definition bawah CIDB. Kategori IBS ni kita boleh nampak, kita memang tadi presenter pertama memang cerita pasal precast system, precast concrete system. Kita ada a few, 6 sistem lebih kurang roughly, dan ada lagi sistem macam modular. Okay, kedua kita ada block work system, reusable formwork system, metal framing system, timber framing system, innovative system. Innovative system ni termasuk yang 3D printing lah. Inovatif ni dia banyak variety, mix any gypsum board, any board mix dengan C-channel tu, consider kita masuk bawah inovatif sistem. Kebanyakannya digunakan untuk projek perumahan-perumahan, rumah masyarakat, rumah-rumah low cost lah. Okay, rumah-rumah low cost bawah SPMB, banyaklah guna inovatif sistem ni, dan juga block work dan juga metal framing. Okay, itu untuk housing. Kalau high rise memang mostly memang kebanyakan either precast ataupun formwork system. Biasanya dua saja. Okay, ini tadi reference untuk semua, lebih clear. Maksudnya first version 2005, 2010, 2018 dan latest adalah pada 2023. Okay, untuk CIS 18. Kita boleh nampak apa itu CIS 18 punya CIS 1823 ni, maksudnya this document outline a streamline and efficient evaluation. Maksudnya panel dah berbincang dari semasa perbangunan CIS 18 ni, which is the methodology untuk assessing and implementation of IBS technological integration ni, kita dah mix dan kita dah tengok in term of current punya industri IBS punya industri punya keperluan lah. Okay. So itu as per 2023 punya version. Kalau lagi 5 tahun atau 4 tahun ada keperluan revise CIS 18 ni, mungkin kita akan revise lah. Sekiranya contoh macam saya nampak sekarang government tengah push untuk sistem what you call it, yang tadi yang sistem PPVC. Government macam nak implement tu, nak start push untuk PPVC, tapi which is PPVC tu kita faham mahal, very expensive. Singapore punya government pun dah stop sekarang, tapi tak apalah, itu government punya side lah. Mungkin mereka nak cuba untuk projek-projek internal government dulu. Okay. So Malaysia memang tak banyak PPVC company, yang ada Permarine bawah EP, lepas tu ada a few yang betul-betul yang precast lah, yang precast tak banyak. Gamuda saya ingat ada, dan a few company lagi lah yang ada. Okay, untuk principle of IBS core ni kita memang ada 4. Kita ada 4 yang main principle. Pertama adalah the use of prefabricated component. Okay, lepas tu the use of memang MS 1064 standard. Okay, lepas tu dia punya repetitive design in term of floor to floor, vertical and horizontal. Lepas tu dia punya productivity enhancing solution dengan technology adoption. Technology adoption ni more to part 3. Dia ada 3 part 1, part 2, part 3. Part 1 nanti saya akan explain, part 1 structure, part 2 wall system, part wall, ketiga adalah part adoption of technology. So kena score kat 3 part tu untuk dapatkan 70. Okay, untuk yang usage of IBS component for structural system ni kita tengok Lepas tu ada usage of IBS component for wall system. Untuk structure adalah part 1. Ini adalah part 1. Adalah IBS component untuk wall system adalah part 2. Standardization component adalah part 3. Okay. Repetition of floor to floor height seperti saya cakap tadi part 3. Productivity enhancing solution and technology adoption juga adalah di bawah part 3. Sebenarnya tuan-tuan boleh score untuk part 3 nanti Part 3 tu 30 score. Part 1 50, part 2 20, part 3 30. Skor part 3 30 terus maksimum. Saya rasa tak susah lah. Nanti kita tengok. Kategori of building ni, kategori of building saya rasa semua dah cover. Tapi kalau kategori of building yang tuan-tuan nak develop tu tak termasuk dalam list ni, boleh tengok balik lah. Mungkin tak perlu implement, tapi saya rasa kita dah cover semua lah. Semua type of building kita dah cover. Ini memang ada dah dalam CIS 18 tu punya standard tu, memang dah masuk kan. Tuan-tuan boleh cari, download. Sekarang download dah tak ada dah. Physical dah tak ada. Download tapi kena beli. 60 tak silap saya. Di bawah website CIDB, boleh download dan boleh terus guna pakai lah untuk reference. Okay. Ini seperti yang saya cakap tadi, part 1 untuk structural system 50 score, 50 point. Part 2 wall system 20 point, dan part 3 untuk ada simplified construction solution ada 30 point. Okay. So hari ni kita tak akan tengok sangat formula. Formula ni bagi saya kita kena ada satu session khas. Di bawah kami kita ada program latihan untuk CIS 18. CIS 18 ni kita punya program tu ada 2 hari. 2 hari ni kita akan ajar in detail macam mana you nak consider untuk buat calculation, dan juga kita akan ajar you deep calculation macam mana nak dapatkan 70 based on the real drawing, real scenario. Iaitu memang kita akan offer to PSP dululah, arkitek dan juga CNL yang berkait. Sebab itu ada subsidi. Daripada CIDB, dan harganya memang bagi saya murah lah. Tak silap saya 300 tak silap saya. Untuk 2 hari semua cover 300. So kalau boleh hantarlah, siapa yang boleh hantar untuk company, on behalf of company pun tak apa. So kita memang akan buka juga kepada PBT. So subsidi tu selagi ada untuk tahun ni, insyaAllah kita akan terima. Okay. Tuan-tuan boleh tengok kat sini. Kat sini adalah dia punya part 1 untuk table 2. Ini yang saya cakap tadi tu, macam mana nak dapat dia punya factor. You guna sistem apa, prefabricated column and beam. Lepas tu untuk slab you pakai prefabricated slab, dapat 1 maksimum. Kalau pakai ni, insyaAllah akan dapat total project tu 90 plus. Okay. So kalau you ambil yang paling minimum, contoh in situ column beam pakai load bearing wall, conventional timber formwork, tapi you pakai slab precast 0.4. So sama juga you boleh tengok kat sini. So selection tu kena hati-hati. Mungkin dapat 0.1, mungkin you dapat terus. Kalau pakai timber ni memang kosong terus, timber kosong. So kalau you mix sikit-sikit dengan ada pakai timber pun minimum dia punya scoring. So memang kena consider table 2 ni, part 1 ni 50, kalau boleh kena score at least 30. Kalau sini 30, part 3 30, part 2 you dapat 15, dah dapat dah 75 lah. Tapi yang ni macam mana nak selection, macam mana ni kena tengok drawing. So kita kena pergi kelas asing lah. Kita kena pergi kelas asing, kita akan ajar macam mana untuk kira ni selection, dan juga semuanya macam mana faktor untuk pengiraan by area. So hari ni saya kata saya tak akan tunjuk lah sebab dia complicated nanti. Roughly saya akan tunjuk sikit lah. Okay. Selepas you buat selection untuk yang sistem ni, you akan nampak sini ada additional factor untuk structural. Kat sini additional factor dia tak banyak tapi membantu. Let's say lah you pakai pre-cut, pre-band reinforcement, prefabricated reinforcement kit, semua yang ini akan ada additional score. Tak banyak, the usage mungkin you pakai in between 50 to 75, you akan dapat additional 0.02. So additional 0.02 kepada ni. Kalau 0.2 you akan dapat 0.22. Kurang macam tu. Okay. Okay, habis untuk part pengiraan structure. Part 1 kat sini adalah untuk roof truss. Sekarang ni saya rasa semua orang dah pakai roof truss kot. Dah tak ada dah rasanya pakai conventional ni. Conventional ni memang automatic kosong kan. Okay. Cuma pada zaman PKP dulu, saya rasa masa kita buat inspection kita ada jumpa lah. Sebab untuk pengecualian levy kami kena pergi site untuk pengesahan. Okay, untuk pengecualian levy. Pengecualian levy masih ada, masih wujud sampai sekarang. So kalau biasanya pengecualian levy ni dibuat oleh kontraktor. So apabila kita pergi tu masih ada isu masa zaman PKP, roof truss ni mereka terpaksa convert kepada kayu dan juga material lain disebabkan atas kapasiti kilang tak tak boleh operation. So tak ada supply. Tapi projek jalan masa tu projek berjalan, construction jalan, tapi tak semua jalan untuk yang supplier lah. Okay, ini untuk part 1. Ini memang kita kena go deep lah, in detail. It's good kalau boleh hadir kita punya kursus training. Training kita tu 2 hari saja. 2 hari saja kita boleh buat dekat hotel, boleh kat tempat tuan-tuan, kalau ada tempat tu pun boleh. Kita boleh berbincang lah untuk part tu. Okay, ini adalah untuk part 2. Tuan-tuan nampak kan, part 2 straightforward. Maksudnya part 2 ni dinding. Tadi kita cerita pasal structure pakai IBS semua. Okay, lepas tu yang ni pasal dinding. Dinding kalau pakai wall panel 1 full score. Kalau pakai drywall system, any apa-apa drywall system, dapat tinggi juga 0.7. Lepas tu kalau pakai in situ concrete permanent formwork, dia akan semakin menurun 0.6, blow up dapat 0.5, dan the rest paling rendah conventional timber kosong. So ini adalah selection yang tuan-tuan kena aware. Okay, untuk part 2 juga ada additional factor, sama juga macam part 1. So kalau ada pakai pre-cut, pre-bend, reinforcement, reinforcement cage, akan ada additional score. Okay. Untuk part ni ada nak tanya apa-apa ke? Tak ada Okay. Saya cepatkan sikit. Okay, untuk yang ni part 3, kita dah pergi part 3 dah. Part 3, dia ada 3 part je, part 1, part 2, part 3. Untuk part 3 ni adalah lebih kepada simplified construction solution. Kalau tuan-tuan nampak, dia ada 3 subkategori sebelum dapat total IBS score. Maksudnya, first subkategori kat sini, utilization of standardized component. Maksudnya, beam, column, wall, slab pakai the same standard size as per MS 164. Kalau in between 50 to 75, you akan dapat 2 saja. Tapi kalau you punya size tu, okay, 75 to 100% comply, you akan boleh terus dapat maksimum 4. 4 ni 16. Kat sini ada 16. Kalau tuan-tuan dapat 16, 6, 14. Kalau kira ni dah terlebih 30. Maksudnya maksimum you boleh dapat 30. So you kena boleh kira you nak fokus yang mana nak dapatkan 30. Okay. Part 1, 16. Part 2, repetition floor to floor. Untuk apartment, straightforward. Kalau pakai repetition floor to floor, memang kita akan bagilah. Maksudnya floor height, dia punya floor height standardized. Kalau 3.5, 3.5 semua. Kalau 3.2, 3.2. Kalau 3 meter, 3 meter. The whole ni lah. Kecuali yang bawah sekali, kalau you buat floor tu, special floor, dan mungkin yang itu kita tak kira lah. Kita kira start daripada yang the rest ke atas saja. Still boleh dapat 4 sebab dia 75 to 100% usage. Lepas tu ini repetition Lepas tu repetition tu juga ada vertical dan juga horizontal repetition. Bukan saja horizontal dan bukan saja vertical. Okay, kita habis untuk part ni. Yang sini ada 6 point. Selepas tu kita ada part 3, productivity untuk enhancing solution technology adoption. Ini adalah totally baru, totally new dalam CS 1823, which is total score dia ada 14. So that's why saya rasa kat sini boleh cuba score. Pertama adalah menggunakan beam level 1 dan beam level 2. Apa beam level 1, apa beam level 2? Beam level 2 ni lebih kepada complete coordination in between architect, CNS, MNE. Itu complete, boleh terus claim as bawah untuk dapat 6 lah. Mungkin guna Revit, mungkin guna apa-apa sistem IRC file ke apa ke, yang itu adalah terus dapat 2. Kalau level 1 ni simply mungkin CAD tapi ada 3D, boleh claim as level 1. So kat sini dah ada 6, kalau dapat 6 lah. Kalau yang lain-lain untuk AI, untuk big data ni, blockchain ni, memang saya rasa straightforward, boleh claim, tapi tak payah fokus semua sebab target maksimum 30 saja. Okay, termasuk juga kat sini ada PPVM, kita ada MEP, tengok projek lah. Kalau klien tu memang projek besar, mungkin dia akan pakai MEP lah. So kat sini 4, prefabricated staircase pun dapat 4. Kalau macam EP punya projek, semua apartment memang sekarang ni semua pakai prefab staircase kebanyakan. Kalau apartment tu memang semua prefab lah. Tak ada dah pakai conventional. Saya tak tahu lah, tak jumpa dah. Kurang lah. Kalau housing mungkin nak save cost. Tapi apartment nak cepat memang dia orang akan pakai prefab staircase lah. Okay, kat sini Last adalah untuk penggunaan untuk self-climbing working platform pun boleh score 2, dan juga usage of the modular grid line. Ini saya rasa untuk grid line, usage of grid line ni typical issue memang di bawah arkitek, saya rasa tak ada issue. As long as you follow the grid line modular, then boleh dapat, either boleh dapat 3 ataupun kalau memang more than 75 dia boleh dapat 6 terus. Kebanyakan company sekarang ni untuk yang pengiraan yang latest version ni memang score kat sini ada yang 30. Full mark lah boleh dapat 30 kat sini. Kalau 30 kat sini, precast system tu dia dapat 30 pun, rendah pun, wall dia dapat 15, dah dapat 75. So kat sini kena tengok juga, jangan tinggalkan lah. Jangan tinggalkan. Okay, ini seperti saya cakap tadi, lebih kurang roughly untuk beam level 1, apakah beam level 1, apakah beam level 2, level 3, level 1. Ini adalah lebih kepada untuk knowledge, saya takkan explain lah. So kita nampak kat sini, kalau level 2 full point tadi adalah lebih kepada coordination in between multiple disciplinary, architect, structure dan juga M&E lah. So nama M&E, terutamanya memang M&E sebenarnya. Okay, almost habis. So kat sini kita dapat simpulkan CS18 ni, sekarang ni CS18-23 ni mandatory requirement untuk mendapatkan obtaining building plan approval. So it's something yang as a PSP kena ambil maklum lah. Sekiranya tidak, nanti kita sebenarnya CIDB punya side pun tak nak lah nanti tiba-tiba PSP kata tak aware. So that's why CIDB hari ni hantar represent untuk cerita sikit pasal polisi dan cerita sikit pasal CS18, kewujudan CS18 yang terbaru. Okay, ini tadi refer to kita punya slide, previous slide. Okay, saya takkan cerita untuk yang ni. Cuma dekat sini saya nak cerita sikit training yang seperti yang saya cakap tadi, tuan-tuan perempuan, tuan-tuan boleh dapati di CIDB IBS. CIDB IBS ni kita ada session, ini antara program-program IBS yang kita ada lah. Okay, pertama yang saya cakap tadi adalah CS18-23. Slot ni masih ada. Tuan-tuan boleh grab, direct dengan kita pun boleh. Nak buat the whole team, tuan-tuan punya ni pun boleh. Nak buat di bawah PEM pun boleh. So kita akan discuss further lah. Okay. Tapi selain daripada untuk CS18, sekiranya ada tuan-tuan nak ambil mungkinlah management training, design training bagi CNS pun kita ada provide. Kita memang dah ada, CIDB memang dah ada modul ni. Cuma sekarang ni modul ni tak menjadi kewajipan lagi. Tak tahulah next nanti kalau dia dah wajibkan untuk apa-apa renewal license ke, so kita akan tengoklah nanti. So benda ni pun tak baru sangat, mungkin baru start dalam 2 tahun. Tapi sekarang ni program-program ni semua ada subsidi. Memang ada subsidi. Okay, memang ada subsidi. So harga dia memang murah. Tekla ni 500 tak silap saya. Kita ada Tekla structure design. Trainer by Trimble. Okay, mana yang pakai Tekla lah. Tapi Tekla ni saya rasa banyak yang pakai Precaster. Kalau architecture dia banyak pakai Revit. So tapi kalau ada yang berminat boleh maklumkan lah, boleh terus kepada website kami CIDB IBS Sdn Bhd. So boleh register terus kat dalam ni. So kita akan maklum nanti. Okay, itu sahaja daripada saya. Terima kasih semua.
Okay, everyone, before we move on to our Q&A session, please remain seated. Can you all, you guys came with a goodie bag, right? Can you all show your goodie bag to me? Because we're gonna take a picture right now. Yes, let's take a crowd picture. Everyone pull up your goodie bag. Yes, show it nicely. Don't cover your face. Put it next to your face. Yes. Thank you, everyone. Thank you. All right. One more, 3, 2, 1. Thank you, everyone. Okay, now we go straight away into the Q&A session. Can I call all the speakers back on stage as we begin to open the panel discussion? Everyone, please give them a big round of applause as they come up on stage. All the speakers from previous session. Please come up on stage. Everyone, you can start scanning this QR code, which will lead you to a form where you can ask your questions right now. So now everyone, we can dive deeper into the ideas that was just shared today. Scan the QR, type out your questions, ask anything you want. Someone asked, is IBS earthquake proof? Is IBS earthquake proof? That is one question we have here.
Hello? Yes, IBS is no different from any other structural system, right? If for conventional system, you can design your building as a normal structure without seismic, or you can also design with seismic. Same goes to precast concrete system. I only can talk on behalf of precast concrete system because IBS is a very wide topic, and under IBS we have precast concrete, we have steel, we have many other systems. So on precast system, yes, it can be designed to cater for seismic design. I believe other systems as well, but I am not a specialist on other systems, so I'm not qualified to answer you on that. Yeah.
Thank you. Another question. Will most of the project our company involved does not require IBS, industrial project, large scale 40 plus acre? Is it depend on Majlis requirement too? Maybe I'll repeat. Will most of the project our company involved does not require IBS, industrial project, large scale 40 plus acre? Is it depend on Majlis requirement too?
Okay, we'll answer this in Malay. Acre, can we convert acre to meter square, meter persegi? Is it? So 43 acre is equal to more than 50 meter persegi, right? Okay. Kalau ikut sekarang punya polisi is a kewajipan, it's compulsory. It's a compulsory to use IBS. If the project total amount of project is 50 million and up to 50 meter persegi for of area, then if both criteria follow, then as a PSP, then you have to it's a wajib lah. You have to follow the policy that I just showed you.
Thank you. Another question we have: could we design a block as a system? Could we design a block as a system? That is one question.
Hello. I don't quite understand what do you mean by block. You mean block work system, is it?
I believe it was the block system you mentioned previously.
Okay,
The PPVC system, is it?
I think so.
And the question is?
Could we design a block as a system?
Certainly where for PPVC, it's very common these days, especially in Singapore, where the sites are getting tighter and the density is getting much higher. So they've got the entire building literally in a PPVC system.
Yeah. Thank you. Another question is, any water ponding test for PBU after installation at site to eliminate damages during transportation?
Water ponding tests will only be done in the factory. So after we deliver the components to the site, no, we won't conduct another water ponding test. I mean, if you want to do it, you can do it on site. The structure is, the unit is watertight. If you want to be very sure, you want to do a second time, go ahead.
CIDB, if the building has parameters that is less than the requirement, example, floor area less than 50,000, etc., do we need to actually apply for exemption?
No need.
No need.
No need. If you will not meet the 2 criteria, then no need.
How to resolve the water leakage issue on the IBS system due to the joint between IBS items?
Yeah, this is a very commonly asked question. Then I want to ask you back. Is in situ structure water leak free? I think the answer is no lah. All right. Okay. So whether it's a precast system or in situ structure or a steel structure, water tightness. How good your water tightness is, it depends on how you detail your structure, how you detail it. Yeah. I mean, we have learned over so many years, and yes, at the beginning there were a lot of things that it was unforeseen, and we learned through all this painful mistake. I think today most of the water tightness issue has been resolved lah. And also nowadays, I think we have a lot of very our technologies has improved tremendously lah. There's a lot of materials that you can use to overcome that. Yeah.
Thank you.
I think a lot of that also comes in your architecture details, because if you actually have allowed for the interlocks to have a drainage channel, and then you incorporate that into your details, it should resolve it. The problem comes is when you don't anticipate for that, and that's when you get the water tightness issues lah. That's one lah. The other one is also in terms of when you actually detail it, how much that workmanship comes in sealing those gaps. That is again an on-site issue lah, just like any other forms of construction lah. So there are two aspects to this lah.
For project under stage billing like the HGA, how do you certify the stage completion for precast system? Can you certify the prefabricated works off-site?
No.
Straight answer. What can architects do to promote IBS in Malaysia?
What can architects do?
Very broad.
Yeah, I think it is good to encourage, but we are always fighting against a cost issue. And that is where that difficulty is. So you will generally have, in broad, two types of clients. The kind of clients who holds on to the money and don't want to let go, and the ones who says, okay, it looks like a good direction forward. And we were having discussions earlier. One of the things that you look at is also in terms of how you look at the value of IBS. Now, in conventional projects, you have the project and you have the defects. And you guys already have the experience that generally in situ work, there's so much defects that you deal with, especially with residential. Your list of defects can go on for years, and there's a cost to that, right? And how well or how badly it's built is very dependent, that amount. If you're able to go on to an IBS system and you actually detail it well, the amount of defects actually reduces significantly, because a lot of it is actually manufactured. So you have to look at it from that point of view. And if you look at that, then it saves you the amount of defect attention that you have to spend money and time on. We have done one of our landed projects actually, where we have used the aluminum strips as our facade instead of your usual brick wall. And we actually had 0 complaints on the facade, no defect. But if you had gone for your conventional plaster and paint, you'd be there sitting there day and night trying to see the differences in your plastering. the reflectivity, etc., etc. So that is actually quite a good testimony to what it is like. And the difference in cost for us in that particular residence, the budget for the aluminium was about 10,000 per facade. 10,000 extra. So it depends on how you look at things. Because we've explained to the developer that if you're selling a property over $1 million, that 10,000 equated back to your defects rectification is going to reduce a lot of your end costs. You know, so as architects, you can share this information and say, look, you know, anything manufactured will be better than something that you have to get a few foreign workers to do on site, because you will never be able to control that quality. You know what? One of our biggest problems is because we rely so much on foreign labor, we don't retain the quality of people that we train. They work here for a few years, then they go back home, you know, and the beneficiary is the country that they come from, because they get trained here and then they go home. You know, there are a few who stay behind, but they don't form the mass of them. You know, so these are some of the things that you can share with your clients, you know, to get a better standard of finishing.
Maybe I can add a bit here. So yes, I think ultimately buyer will be developer or the end user. It's all about value, right? What kind of value, if I use this system, what value do I get? Of course, if you use IBS system, if you compare just the IBS to conventional, IBS always looks higher. But what we will normally advise the user or the end user or the developer to look at is look at the overall cost in totality. Right? Direct material cost is one thing. Don't forget, like just now Mr. Ir Ng say, quality is also one thing, and time is also another thing, especially if you are involved in industrial buildings or commercial building. I mean, time is money. That's what people say. So you can save a lot of times using IBS system, right? And thirdly, I think this is something that most people forgotten. In every construction site, there will be rubbish generated, and throwing away rubbish is no longer free nowadays. If you if you are a contractor, I don't think you can just ask your workers, they just throw this rubbish away. They have to engage the specialist or whoever collector, with licensed collector, and they need to throw at a designated place, and that involves cost. And I hear from some contractors, throwing rubbish, especially if your job is big, costs millions. So by using IBS, you can eliminate all these costs. With all this cost saving, time, labor, quality, rubbish, you add everything up, then you put it into your total construction cost, and you see which one actually benefit you more. I think that the value speaks loud. I mean, speaks loud. Ultimately, if the system can create value to the projects, I think your client or the developer will sure buy in. Yeah.
I pun nak share sikit, actually comment sikit on this issue. Actually bukannya baru, actually it's not new. In the site, CIDB site, kita memang CIDB ada buat a few case study, and the different normally around 10% only, 10% the increase, the price increase for using the IBS around 10%. Okay, the ultimate selalunya adalah because of the quantity lah. The more quantity, the unit, memang you akan boleh fight against the conventional. Okay, ada satu case study saya nak share sikit lah, which is kita buat based on daripada SPNB punya project. Okay, SPNB project which is a housing rumah masyarakat rumah masyarakat. SPNB still allow conventional system. Based on daripada kita punya case study tu, Menggunakan sistem konvensional dengan adalah cost dia adalah 60,000. Let's say lah 60,000. Tapi sekiranya menggunakan sistem other than conventional, sistem IBS yang lain, the cost reduce to 53, 54, 55, which is the contractor akan dapat extra margin selepas menggunakan sistem IBS. Dewan case study kita buat dengan pihak SPMB. Maybe because of the speed sistem IBS under SPMB only 1 month completion, tapi conventional 3 month. So 3 month you punya labor charge, labor fee memang akan increase 3 times. Akan increase 3 times, tapi because of kalau you guna IBS for 1 month you dapat increase, you akan deposit a lot. Okay, so based on the case study tu, for housing only kita dapati harga memang boleh reduce by using precast system. Okay, tu je kita boleh share sikit lah. Thank you.
Thank you so much to all our speakers. I believe our time has already run out actually, so I'm so sorry everyone. You guys had so many questions but we could not make it in time. Well, ladies and gentlemen, what an incredible session we've had today at our technical talk for PAM CPD Unlimited. I hope you found the insights shared as inspiring as valuable as I have. Until next time, stay curious, keep learning, and we will see you at our next event.